Hello there, and welcome once again to Science for Sleep, the place where curiosity winds down with you at the end of the day, where questions about the universe drift as softly as the breath before sleep. Tonight, I'd like to invite you into one of the most mysterious regions ever imagined, a place so far from the warmth of our sun that it's more myth than map. It's called the Oort Cloud, and some astronomers suggest it may be the real boundary of our solar system. Others wonder if it's not just the edge of the system, but something stranger, a threshold where the idea of reality itself begins to blur. Before we settle in, let me ask you something simple. Where are you listening from tonight? And what's the time on the little clock in your corner of the world? I always find it grounding to think that while one person may be hearing this during the quiet stretch of midnight, another might have the golden haze of evening still clinging to their window, and someone else may be starting their morning, already sipping their tea or coffee. A topic about the edge of reality, yet we're each sitting in our own present moment, scattered across the globe, connected by nothing more than a voice and a bit of curiosity. If you find yourself enjoying this calm exploration, if the thought of letting science settle you toward rest appeals to you, I'd be grateful if you chose to like this little corner of the internet and perhaps subscribe. It helps more than you might think. And more importantly, it helps other people, maybe people who need something steady and gentle tonight, to find their way here too. So now, let's dim the pace of the day. Let's imagine we're lying back beneath an endless dome of stars, the world quieter than usual, and let's begin our drift outward. The Oort Cloud is, at first glance, not even something you can point to. No telescope has ever photographed it. No spacecraft has ever flown through it. It's more an idea than an image, a kind of invisible sphere of icy fragments that supposedly stretches nearly a light year away from the sun. Astronomers believe it exists because of the way comets arrive at us from every direction, as if they were shaken loose from a gigantic, all-surrounding reservoir. When we see a comet sweep across the sky, we may be seeing a visitor from this unseen halo, a tiny messenger from a place so distant that sunlight itself is only a faint whisper. But I don't want to jump too quickly to distances and numbers. Before we think about how far the Oort Cloud might be, or how thinly its frozen pieces are spread, it's worth slowing down and imagining what it means for there even to be an edge. Our solar system feels so big already, doesn't it? Planets circling in their endless orbits, moons dancing around them, asteroids scattered like crumbs across the dark. And yet, all of that, from Mercury to Neptune, from Saturn's rings to Pluto's lonely track, is thought to be just a small inner zone compared to the vast halo that may extend beyond. When Jan Oort, the Dutch astronomer, first proposed the existence of this cloud in 1950, it was an elegant way to explain a puzzle. Comets keep appearing. Some have orbits that bring them back around the sun again and again, like Halley's Comet, reliable if a bit dramatic. But others arrive once and vanish into the deep, never to be seen again. Where did they all come from? Why weren't they exhausted long ago? The answer, Oort suggested, was that an enormous reservoir must exist, filled with trillions of icy bodies, each waiting in silence until something nudges it inward. A passing star, the gentle tug of galactic tides, perhaps even the echo of ancient collisions. Whatever the cause, one of these icy fragments is jolted into a new trajectory, beginning a long, slow fall toward the light, melting and brightening as it approaches, briefly dazzling us before retreating back into obscurity. If that's true, then the Oort Cloud is more than a distant belt of debris. It's the invisible skin of our solar system. It's the part of us that brushes up against the wider galaxy. Imagine Earth as your home, the planets as your neighbourhood, the Kuiper Belt as the city limits. The Oort Cloud would then be like a faint outline of countryside, a wilderness that encircles the whole settlement and blurs gently into the forests of other towns. In that sense, the Oort Cloud is not just a structure, it's a borderland, and borders always invite questions. Does what lies beyond belong to us, or does it belong to something else? Is there even such a thing as an edge? Or is the universe more like an unbroken continuum where boundaries are just our own invention? And here, in this thought, lies why so many people feel a strange pull when they first hear about the Oort Cloud. It's not just a scientific curiosity, not just a cluster of cold fragments. It's a symbol of the unknown, a ring of mystery sitting just far enough away to remain untouchable, yet close enough that it belongs, in some sense, to us. Think of how often edges in our lives take on that same aura. The edge of the sea where the land stops and the waves begin. The edge of childhood when memory becomes sharper and we suddenly realise we're part of a bigger story. The edge of sleep, where you're right now perhaps, drifting between awareness and dreaming. Each edge feels like both an ending and a beginning, and the Oort Cloud offers that same feeling on a cosmic scale. As we picture it, imagine the faintest light of the sun, a dot so distant that even daylight would feel no stronger than the glow of a bright star. The comets out there are frozen to the core, undisturbed for billions of years. Some of them might have been drifting in that icy solitude since the very birth of the solar system, never once warmed by the inner sun, never once melted, preserved like time capsules. To hold one in your hand would be like shaking hands with the dawn of planets. But of course, no one has gone there. No one has brought back a fragment of the Oort Cloud. It is, in a sense, the most human kind of place. Imagined, inferred, pieced together from evidence. We see the traces of its existence only when something escapes from it. Like shadows hinting at an unseen structure, the comets are the footprints left behind by this great, invisible herd. And so, here at the beginning of our exploration tonight, we find ourselves not at the Oort Cloud itself, but at the threshold of imagination. To talk about it is already to acknowledge the edges of what we know, the points where evidence blends with theory. Yet that's not a weakness. It's part of the magic of science. The Oort Cloud, whether exactly as we imagine or slightly different, reminds us that the universe is not finished revealing itself. As you lie here listening, you might find yourself wondering what it would feel like to actually travel outward, to leave behind the warmth of Earth, the familiar paths of Mars and Jupiter, and keep going. Past the asteroids, past the realm of Neptune, into the thin belt of the Kuiper objects, and then further still until the sun begins to shrink behind you. Days and nights would lose meaning, for there would be no sunrise anymore, only the faint glow of a faraway star, your star, still yours, but already fading into background. Eventually the darkness would deepen so much that only the distant constellations would keep you company. And somewhere out there, surrounding you on all sides, the first grains of the Oort Cloud would begin to appear, scattered like invisible dust motes in an ocean of a night. That is where our journey is heading, but for now, let's rest in the thought of it. Let's carry with us the idea that perhaps the edge of reality is not something abrupt, not a cliff or a wall, but a gradient, a soft fading, the way the colours of twilight melt into night. When you hear the words Oort Cloud, it can sound almost like a phrase from mythology, as if it belongs alongside stories of ancient gods or whispered legends of hidden realms. In a way, that isn't far from the truth, because what we call the Oort Cloud is not something we have ever directly seen. No spacecraft has sent back a photograph of it, and no telescope has captured a picture of its icy borders. Instead, it lives in the space between evidence and imagination, a scientific legend born not from myth, but from mathematics and the careful noticing of patterns. And like many legends, the more you linger on it, the more it grows into something larger than itself. The Oort Cloud is thought to be a vast, spherical shell of icy bodies that surrounds our solar system in every direction, a halo that might stretch almost a light year away from the sun. To give you a sense of how immense that is, think of Pluto, the little outpost planet we once considered the 9th member of our solar family. Pluto orbits at about 40 times the distance between Earth and the Sun. The inner edge of the Oort Cloud is believed to begin thousands of times farther out than that. If Pluto were a neighbour just a few houses down the street, The Oort Cloud would be like a countryside so distant you'd need months of travel just to reach the first fence. What makes this halo so fascinating is that it changes the way we think about the solar system. When most of us picture our home in the cosmos, we imagine the planets circling in a flat disk, the sun blazing at the centre, and perhaps a belt of asteroids somewhere in between. But if the Oort Cloud is real, and most astronomers believe it is, then the solar system is not just a flat disk. It is wrapped in a giant shell, a three-dimensional sphere that encases everything we know. That changes the geometry of our mental picture. It turns the solar system from a platter into a bubble, from something spread thin into something fully enclosed. This sphere is thought to contain perhaps trillions of icy fragments, ranging in size from tiny grains to mountains as large as small planets. Each one is a frozen leftover from the early days of planet building, when the sun was young and the planets were still forming. Some pieces may be rich in water ice, others in carbon compounds, others perhaps in exotic mixtures we have never touched. To imagine standing on one of them, if such a thing were possible, would be to feel silence so deep it would ring in your ears, a darkness so perfect it would make even the stars look bright and close. You would see the sun as nothing more than a distant star, indistinguishable from thousands of others scattered across the sky. And you would know that you were still technically part of the solar system, yet already on the doorstep of interstellar space. But how did these icy fragments get there in the first place? The story, as scientists reconstruct it, begins billions of years ago, when the solar system was still a swirling disk of dust and gas. Out of this disk, planets condensed, pulling material together under the steady hand of gravity. But not all of that material stayed neatly close to the planets. Some of it was flung outward by gravitational encounters, tossed like pebbles from a sling. Over time, enough of these scattered fragments settled into elongated orbits, drifting farther and farther away until they formed a kind of distant, diffuse cloud. Like crumbs scattered around a kitchen after baking bread, these icy bodies became the leftovers of creation, no longer bound to the warmth of the inner system, yet still held by the faint but persistent gravity of the sun. Astronomers suspect that the Oort Cloud is not a dense swarm, not something you would see as a solid wall if you could approach it. Instead, it is more like a vast emptiness sprinkled with occasional objects separated by enormous distances. To picture it, you might think of standing in a desert at night, grains of sand spread across the ground beneath a sky filled with stars. Each icy body in the Oort Cloud is like one of those grains, small, far apart, and surrounded by endless dark. Yet together, they add up to a structure that defines the boundary of our solar system. We know of its existence not because we have touched it, but because we see its fingerprints. Long-period comets, those that sweep in from far beyond Neptune and then disappear again for thousands of years, betray the presence of a reservoir that feeds them. Their orbits are scattered in all directions, not aligned like the planets, or even like the Kuiper belt. That randomness suggests a spherical source, and the simplest explanation is a great surrounding cloud. Jan Oort, who first proposed it, did so after carefully studying the paths of comets, noticing patterns that made no sense unless they originated in a distant sphere. His insight reshaped our cosmic map, reminding us that what we cannot see may be just as real as what we can. In some ways, this makes the Oort Cloud one of the purest examples of human imagination grounded in science. We cannot point a camera at it, we cannot yet send a probe, and yet by tracing the arcs of icy travellers, by watching how gravity tugs and pulls, we build a picture of something invisible. It is as if we were mapping a forest not by walking through it, but by catching glimpses of birds that fly from its edges. From their flight paths, we infer the shape of the trees, the depth of the woods, the presence of something more. That idea alone has a kind of quiet beauty, because the Oort Cloud shows us how science often works. We don't always see directly. Sometimes we listen for echoes, we notice footprints, we connect patterns, And from those patterns we draw out the shape of hidden realities. In that sense, the Oort Cloud is not just a physical place but a lesson in perception. It also reminds us of scale. The distances involved are almost impossible to imagine. Voyager 1, the most distant human-made object, has been travelling outwards since 1977. It has crossed into interstellar space, yet by most estimates, it hasn't even reached the inner edge of the Oort Cloud. At its current speed, it might take another 300 years just to get there, and tens of thousands of years to cross through it entirely. That means the Oort Cloud is not just far away. It is unimaginably vast, so large that human exploration of it is something we can only dream of, not yet planned for. And yet, it may be the region that most fully defines where our solar system ends and the galaxy begins. To call it a halo feels appropriate, because a halo is something that surrounds, something that crowns, something that hints at significance. The Oort Cloud is our solar halo, a borderland of ice and silence that both protects and hides. It is thought that most of its objects are stable, content to drift for billions of years without disturbance. But now and then, a disturbance comes, and that's when a comet is born. A passing star, a subtle pull from the galaxy itself, a chance encounter can send one of these icy travellers inward. And when that happens, we see it. It brightens in our skies, it grows a tail, it becomes a spectacle, and then it reminds us that every comet we have ever seen, every streak of light that has sparked wonder in human eyes, may have begun its journey in this invisible halo. It is strange to think that the stories we tell about comets, omens, portents, symbols of change, are really stories about the Oort Cloud, because those comets are its emissaries, the only visible pieces of it that we ever glimpse. When ancient people looked up and saw a comet blazing across the sky, they were, without knowing it, witnessing a fragment of the halo. They were seeing the farthest edge of the solar system made visible for a moment. In that way, the Oort Cloud has been part of human imagination long before we had a name for it, long before Jan Oort put it into equations. And so, as we rest in the thought of this halo, it becomes not just a scientific concept, but a symbol of distance, of boundary, of hidden things. A reminder that even our home system, familiar as we might feel about the planets and their orbits, is still wrapped in mystery. If the Oort Cloud is a halo, a great surrounding shell of frozen fragments, then it leads us naturally to a question that is both simple and unsettling. Where does the solar system end? We talk about edges and borders as if they're lines on a map, clear and sharp. But when you try to draw such a line in space, it refuses to stay still. It blurs, it fades, it stretches. What seems like a border one moment becomes a region the next, and what feels like an ending often leads seamlessly into something else. For much of human history, the solar system was only as big as the eye could see. The ancients looked up, saw the bright wanderers moving against the backdrop of the stars, and called them planets. Beyond Saturn, there was nothing visible, nothing that could be tracked without instruments. The edge of the solar system was Saturn itself, a ringed giant glimmering at the horizon of human imagination. It took centuries, telescopes, and persistence to reveal more, to discover Uranus, Neptune, and finally Pluto. Each new discovery pushed the boundary farther, redrew the edge, stretched the map, and even now, when we have sent probes beyond Pluto, the question of where the solar system truly ends remains unsettled. There are several ways to define it, each with its own logic. One way is by the reach of the sun's gravity. Gravity is what holds the planets in their orbits, what keeps comets tethered, what binds the system together. But gravity never really stops. It weakens with distance, fading into smaller and smaller pulls, but it doesn't vanish. Even trillions of kilometers away, the sun still exerts a faint tug. By that measure, the solar system never ends at all. It stretches forever, with the sun's gravity reaching across infinite space. Another way is by the reach of the solar wind, the stream of charged particles that flows outward from the sun in every direction. This wind forms a bubble, called the heliosphere, around the solar system. Inside it, particles from the Sun dominate. Outside it, particles from the wider galaxy begin to take over. The boundary where the solar wind slows and collides with interstellar space is called the heliopause, and this is sometimes called the true edge. Voyager 1 crossed it in 2012 after 35 years of travel, making it the first human artifact to leave the solar bubble. Yet even beyond the heliopause, the Sun's gravity still extends, still binds the Oort Cloud. So which edge is the real one? The edge of influence or the edge of wind? Then there's the Oort Cloud itself. If it exists as we imagine, then it might be the best candidate for the outer limit of the solar system. Objects in the Oort Cloud are still loosely tied to the Sun's gravity, still part of the solar family, yet they are so distant that the galaxy itself has almost equal claim to them. It's a liminal region, a twilight zone where the pull of the Sun and the tug of the stars compete. Some astronomers consider the farthest reaches of the Oort Cloud to be the practical end of the solar system, because beyond that, the influence of the Sun is simply too weak to dominate. Beyond that, an object belongs more to the galaxy than to the Sun. But even here, the word end feels misleading, because the solar system doesn't stop like a road hitting a wall. It fades, it thins, it becomes gradually less certain, like the shoreline of an estuary where river meets sea. Imagine standing at that shoreline. On one side, the fresh water of the river flows. On the other, the salty ocean stretches away. But between them, there is a zone where the two mix, where it's hard to say where one ends and the other begins. The solar system is like that. It doesn't terminate. It blends into the wider galaxy. This blending invites strange questions. If you could somehow travel outward, leaving Earth, passing Mars, drifting past the gas giants, sailing beyond Pluto, and finally reaching the scattered disk and Kuiper belt, would there ever be a moment when you could say, definitively, now I have left? Probably not. There would be no cosmic signpost, no sudden transition. Instead, there would be gradual changes. The density of solar particles would drop, the comets would grow rarer, the Sun would shrink into a background star, and eventually the stars of the galaxy would begin to claim more of your attention than the faint pull of the Sun. Even Voyager 1, as it crossed the heliopause, experienced no sudden jolt. Instruments detected a shift in particle density, a change in the magnetic field, but to a human traveller, the view would have been the same. Darkness, stars, a distant Sun. The boundary is scientific, not experiential. You can measure it with instruments, but you cannot feel it. And perhaps that's what makes the idea of an edge so compelling. We long for borders, for lines that mark beginnings and endings. But space teaches us that most borders are gradients, most endings are transitions. The question of where the solar system ends also touches on philosophy. Because if we can't point to a line, then what does it mean to belong? Does the Oort Cloud belong to the solar system, or does it belong to the galaxy? If an object drifts for billions of years on the edge, perturbed by passing stars occasionally nudged inward, is it ours or is it shared? These questions mirror the way we think about ourselves. Where do we end, and where does the world begin? Are we defined by our skin, or by our interactions, our influences, our ties? The Oort Cloud, in this sense, is a metaphor for identity as much as it is a scientific region. Consider too that what we call the end of the solar system may depend entirely on what we are measuring. For some scientists, the edge is defined by radiation, for others by magnetic fields, for others still by gravitational binding. Each perspective is valid, yet none is final. The solar system, like reality itself, resists neat labels. It stretches beyond the categories we try to place on it. There is also the question of interstellar visitors. In recent years, objects like Oumuamua and Comet Borisov have been detected passing through our system. They came from beyond, from the interstellar void, crossing through our Sun's domain before slipping away again. Their presence reminds us that the boundary is porous, Things do not simply stay inside or outside. They cross, they wander, they blur the line. The solar system is not an isolated island. It is an archipelago in a sea of stars, and its edges are constantly lapped by galactic tides. Imagine, for a moment, that you were on one of those interstellar travellers, a fragment of rock or ice, born in another system, set adrift by a gravitational encounter eons ago. You drift for millions of years, perhaps billions, until finally you approach the faint glow of a distant star. Its gravity tugs you, its light brushes your surface, and for a time you pass through its domain. Then, just as quietly, you continue on into the void, carrying with you no sense of edges, no map of borders, only endless night. From the perspective of such an object, the idea of where one system ends and another begins is meaningless. There is only travel, only drifting, only change. And yet for us the question matters, because we want to know where we are. We want to know what belongs to us and what lies beyond. We crave the comfort of maps, even when the universe refuses to be mapped neatly. Perhaps the Oort Cloud is not just a scientific structure, but a reminder that edges are often illusions. They are useful illusions, necessary for navigation and understanding, but still illusions. The truth may be that the solar system does not end. It simply dissolves into the galaxy, and the galaxy itself may dissolve into larger structures, each boundary fading into the next. Still, when we speak of the edge of the solar system, we are really speaking of a region where our influence gives way to something larger, where the familiar gives way to the unknown, where the story of the planets yields to the story of the galaxy. It is a place that symbolizes transition, and transitions are always powerful. They remind us that nothing is fixed, that all things are in motion, that endings are beginnings in disguise. The Oort Cloud embodies this truth. It is the place where the solar system does not end, but rather hands itself over to the galaxy, where the identity of our system becomes porous, where belonging becomes shared. When we think of the Oort Cloud, it can feel almost too abstract, too far away to hold on to. But there are visitors that come to us from that region, reminders that the distant halo is real even if invisible. These visitors are comets, the icy messengers that cross the void and blaze through our skies. In a way, every comet is a letter delivered from the edge, a message written in ice and dust that tells us something about where it came from and what it has endured. Comets are among the oldest objects in the solar system. Their cores are thought to be leftovers from the early days of planet formation, frozen relics that never grew large enough to become planets or moons. For billions of years, they have drifted in the cold, preserving within them materials that date back to the birth of the sun itself. When one of them is nudged from its distant orbit and begins its long fall toward the inner solar system, it carries with it those ancient ingredients, locked away until sunlight sets them free. The journey of a comet is slow at first. Imagine a fragment in the Oort Cloud, resting in the deep cold, far beyond the warmth of any star. For countless millennia, it drifts quietly, pulled slightly by the faint tug of the sun but otherwise untouched. Then, perhaps because of the subtle pull of a passing star, or the collective influence of the galaxy's tides, its orbit changes just enough to set it on a path inward. At first the change is imperceptible. The comet may take millions of years just to cover the first fraction of the distance. But as it falls closer to the sun, gravity strengthens, speed increases, and the slow drift becomes a plunge. As it nears the inner solar system, something remarkable happens. The sunlight, which was once just a faint glow on the horizon, becomes warm enough to awaken the comet. Ices that were stable for billions of years begin to sublimate, turning directly into gas. Dust trapped within the ice is released, creating a haze around the solid core. This haze, called the coma, can be thousands of kilometers wide, a ghostly atmosphere surrounding a nucleus, often no larger than a mountain. As the solar wind catches the gas and dust, it stretches them out into a tail that always points away from the sun. That tail can be millions of kilometers long, a luminous brushstroke across the night sky. From Earth, such a sight can be breathtaking. Throughout history, comets have appeared suddenly, often brighter than the stars, moving perceptibly night by night. For ancient people, they were both wondrous and terrifying, omens of change, symbols of upheaval. Kings feared them, poets described them, astronomers tried to chart their paths. And yet, what they were truly seeing was something deeply ordinary and deeply profound at the same time. An icy fragment of the solar system's beginnings, lit up by the warmth of the star we call home. Not all comets come from the Oort Cloud. Some belong to the Kuiper Belt, closer in, a region beyond Neptune filled with icy bodies. These comets tend to have shorter orbital periods, circling back around the Sun every few decades or centuries. Halley's Comet, for instance, is one of these. It has been recorded for thousands of years, appearing roughly every 76 years, returning reliably enough that it can be predicted. But the long-period comets, the ones that might take thousands or even millions of years to return, those are the ones that likely come from the Oort Cloud. They can appear from any direction, their paths tilted and scattered, arriving like strangers with unfamiliar accents. Their very randomness betrays the presence of the vast spherical reservoir surrounding us. In that sense, comets are the only direct evidence we have of the Oort Cloud. We cannot see the cloud itself, but we can see its ambassadors. Each comet that flares through the sky is proof that the halo exists, that the solar system is not just a disk of planets, but a sphere with icy edges. To watch one is to witness the invisible made visible, the distant made tangible. There is also something poetic about the way comets live two lives. In the Oort Cloud they are silent and dark, frozen time capsules drifting without witness. But when they enter the inner solar system, they become luminous, dramatic, impossible to ignore. They are both introverts and extroverts, hidden for eons, spectacular for weeks, and then just as suddenly they fade again, retreating back to the silence. It is as if they were born to remind us briefly of the vastness we cannot see before disappearing again into it. Scientists study comets not only for what they reveal about the Oort Cloud, but also for what they reveal about ourselves. Some theories suggest that much of Earth's water may have originally come from comets, delivered in the planet's youth during a time of heavy bombardment. Others propose that comets may have carried organic molecules, the chemical seeds of life, to our world. If that is true, then the Oort Cloud is not just the edge of the solar system, it is part of the story of why we're here at all. To think that the water in your glass or the molecules in your cells might once have been locked inside an icy fragment drifting on the farthest edge of the system is to feel a connection that stretches across billions of years and trillions of kilometers. But comets are also reminders of fragility. Their paths can be unpredictable. They can collide with planets, as happened with Jupiter in 1994, when fragments of comet Shoemaker-Levy 9 slammed into its atmosphere, creating scars larger than Earth itself. Such impacts remind us that comets are not only messengers, but also hazards, capable of reshaping surfaces, altering climates, and changing histories. In the past, impacts from comets or asteroids may have played roles in mass extinctions on Earth. The dual nature of comets, bringers of water and life, bringers of destruction, gives them a mythic weight. They are both creators and destroyers, gifts and warnings. Even so, there is a quiet dignity in their journeys. To imagine a comet's orbit is to imagine patience beyond measure. A single trip around the Sun might take longer than all of recorded human history. For a comet, centuries are the blink of an eye. Millennia are routine. They are travellers whose timescales dwarf our own, and yet we notice them because they happen to flare in our skies during our brief lifetimes. It is a reminder that the universe is full of stories unfolding on timescales so vast we can only glimpse fragments of them. When you next think of the Oort Cloud, it may help to think of it not as an empty abstraction, but as the silent birthplace of comets. Each streak of light across the sky, each glowing visitor that leaves us staring upward in wonder, is part of its legacy. Comets are the proof that the edge exists, that our solar system does not fade into nothing but extends into a halo of frozen messengers. They carry the memory of the beginning, they travel through the present, and they hint at futures we can scarcely imagine. And as we lie here thinking about them, it is worth remembering that some of those comets are already on their way inward, right now, falling slowly toward the sun. They may not arrive for centuries, perhaps millennia, but their journeys have begun. And one day, someone will look up and see them, just as people have for thousands of years. The cycle will continue, the messages will keep arriving, and the edge of the solar system will keep reminding us that it is there. The comets that sweep across our skies are more than beautiful accidents. They are patterns, repeating enough to invite explanation. And every pattern, if noticed carefully enough, has the power to reshape our understanding of the universe. That was exactly what happened in the middle of the 20th century, when a Dutch astronomer named Jan Oort began to study the strange paths of comets. His curiosity, sharpened by patience and calculation, gave birth to an idea so vast that it extended the borders of the solar system 1,000 times farther than anyone had imagined. Oort was born in 1900, the very start of a century that would transform astronomy. He grew up in the Netherlands, in a world lit not by satellites or digital screens but by lamps and telescopes. As a young man, he studied physics and astronomy at the University of Groningen, a path that soon led him into the orbit of some of Europe's greatest thinkers. He had a quiet manner but a restless mind, the kind of mind that could stare at data not just for what it said directly, but for what it implied. By the 1920s, he was already working on the structure of our galaxy, showing how stars orbit around its centre. His name became known for what we now call Oort's constants, mathematical descriptions of how stars move in the Milky Way. But it was in 1950, at the age of 50, that he published a paper that gave his name to something stranger still, the Oort Cloud. At the time, astronomers had catalogued hundreds of comets. Their orbits varied wildly. Some circled the sun in predictable loops, short periods that brought them back again and again. Others appeared suddenly, from directions no one expected, then vanished, never to return. If all comets were created near the planets, then they should have been used up long ago. Their ices would have evaporated after repeated visits, their cores reduced to dusty remnants. And yet, new comets kept arriving. Where were they hiding? Oort looked at the data with the same clarity he had once brought to galactic rotation. He noticed that many comets seemed to come from extreme distances, their orbits starting not near the planets but far, far beyond. They did not share the flat, disc-like arrangement of the planets. Instead, they came from all directions, as if from a spherical distribution. To explain this, Oort proposed that the solar system was surrounded by a vast cloud of icy bodies, a spherical shell extending almost a light year away. This cloud, he argued, was the reservoir from which comets came. It held trillions of objects, frozen since the earliest days, waiting in silence until some disturbance sent them inward. The idea was bold. It pushed the boundary of the solar system unimaginably outward, beyond what any telescope could see, beyond what any probe could reach. And yet, it was elegant. It explained the random directions of long-period comets. It explained why comets were still appearing after billions of years. It explained their distribution, their behaviour, their persistence. It turned chaos into pattern, accident into design. At first, the Oort cloud was purely theoretical. There was no way to see it directly, no way to confirm it except through the comets themselves. But over the decades, the idea held strong. Each new observation of a comet's orbit added weight to the hypothesis. Each visitor from the farthest reaches of the system whispered confirmation. Today, most astronomers accept its existence, even though not a single object within it has ever been observed directly. It remains one of science's most accepted unseeable places. Oort himself did not limit his work to comets. He He was one of the pioneers of radio astronomy, using radio waves to map the Milky Way. He studied the distribution of hydrogen gas, the fuel of galaxies. He served as director of the Leiden Observatory, guiding generations of astronomers. His career spanned decades, marked by patience and vision. But it is the cloud that bears his name that remains his most enduring legacy. To appreciate his insight, it helps to remember the time in which he worked. In 1950, no spacecraft had yet left Earth. No one had seen Earth from orbit. The outer planets were still distant dots in telescopes. The idea of a halo of trillions of icy bodies surrounding the system was almost fantastical, and yet Oort's calculations made it not only plausible, but necessary. He expanded the solar system in a single paper, turning it from a disk of planets into a sphere of mystery. There is something fitting about this, because comets themselves had long been symbols of mystery and change, feared by some, admired by others. By explaining them, Oort did not strip them of wonder. He gave them context. He showed that their brilliance was not random, but part of a larger structure. He connected the sudden blaze of a comet in the sky to the invisible depths of the solar system, tying human experience to cosmic architecture. It is worth pausing to imagine him at his desk, surrounded by charts of cometary orbits, pencil in hand, calculating the parameters of paths that stretch beyond any telescope's view. It must have felt like tracing footprints that disappeared into mist, then realizing that the mist itself had shape. To take the scattered data of comets and infer from them the existence of an entire cloud was an act of vision, almost poetic in its daring. Yet it was rooted in careful numbers, in mathematics, in the steady application of a logic. That balance between imagination and discipline is what defines great science. The Oort Cloud may bear his name, but the idea also represents a larger truth, that the universe is not limited to what we can see, that sometimes patterns tell us of things far beyond direct observation, and that patience, the patience to look at orbits and trajectories and notice their implications, can reveal worlds that lie beyond imagination. Oort lived long enough to see space exploration begin. He saw satellites launched, probes sent to other planets, astronauts walking on the moon. He saw radio astronomy expand, mapping galaxies, detecting quasars, uncovering cosmic backgrounds. Yet the cloud he had proposed remained untouched, unreachable, invisible. Even today, decades after his passing in 1992, it remains beyond our reach, and perhaps that is part of its lure. Because the Oort Cloud is not just a scientific structure, but a reminder of the limits of knowledge, a horizon we can point to but not yet cross. When you hear the phrase, the Oort Cloud, it may sound cold, distant, impersonal, but behind it is the story of a man who looked at comets and saw a pattern, who dared to suggest that the solar system is far larger and stranger than anyone had believed. It is a story of human curiosity, of quiet persistence, of the ability to see in the flicker of comets the outline of a cosmic halo. And so, when the next comet appears in the sky, trailing its luminous veil across the darkness, it will be worth remembering not only the ice and dust within it, but also the man who gave it context. Each comet is not just a visitor from the edge. It is also a confirmation of Jan Oort's vision, a messenger not only from the Oort Cloud, but from the human ability to imagine what lies beyond sight. When we last thought about Jan Oort and the great cloud that carries his name, we were still close enough to our solar family to recognize the comets that fall inward as its messengers. But before reaching that imagined halo of icy fragments, we must pass through another realm, a region that lies just beyond the most distant of the classical planets. To travel there in the mind is to step into a zone of darkness that begins after Neptune, a place where the warmth of the sun has already thinned, where the shadows of planets give way to the first taste of the true vastness beyond. Neptune itself feels like a frontier. It circles the sun at about 30 times the distance of Earth, an enormous blue giant cloaked in methane clouds, winds roaring faster than sound. It is the last of the 8 planets we count today, the outer sentinel of the planetary system. For centuries it was unknown, discovered only when astronomers noticed oddities in Uranus's orbit and realized another planet must be tugging at it from farther out. Its discovery in 1846 was a triumph of mathematics, proof that the unseen could be predicted. And yet, even with Neptune in place, the solar system did not end there. Beyond Neptune lies a region once thought empty, but now known to be full of icy bodies. This is the Kuiper Belt, a disk of small frozen objects extending tens of astronomical units outward. Pluto, once called the 9th planet, is one of its most famous residents, a world of ice mountains and nitrogen plains orbiting with hundreds of others. The Kuiper Belt is sometimes described as a second asteroid belt, but colder, larger, and more mysterious. Where the asteroid belt is full of rocky debris from the inner solar system, the Kuiper Belt is full of frozen remnants from the outer regions, material that never formed into large planets. And yet, the Kuiper Belt is only the beginning. Beyond it lies the scattered disk where objects move on eccentric, tilted orbits shaped by Neptune's distant gravity. Some of these orbits are so stretched that they take thousands of years to complete, dipping close to Neptune on one end and swinging far into the dark on the other. These scattered disk objects are like wanderers, unsettled, pulled between the order of the planetary system and the emptiness beyond. The most famous of these distant wanderers is Eris, discovered in 2005, a dwarf planet slightly smaller than Pluto but more massive. Its discovery triggered the debate that ultimately redefined what a planet is, demoting Pluto to dwarf status. Eris, along with other large objects like Haumea and Makemake, showed that Pluto was not unique but part of a larger population. The solar system, once thought to end with Neptune, was revealed to have a whole community of worlds beyond, each icy, each strange, each reminding us that endings are often only beginnings in disguise. As you imagine travelling beyond Neptune, it helps to think about light. Here on Earth, daylight is bright enough to fill every corner, sharp enough to cast strong shadows. Even out at Jupiter, the sun still shines 100 times brighter than the full moon does on Earth. But by the time you reach Neptune, sunlight is already weak, barely strong enough to illuminate the clouds of the giant. And as you go farther, into the Kuiper Belt and beyond, the sun becomes no more than the brightest star in the sky. It would still be the centre of your world, still the source of gravity and warmth, but visually it would lose its dominance. You would begin to feel, in a literal sense, the vastness of space. The scale is staggering. The Kuiper Belt extends perhaps 50 astronomical units from the sun. The scattered disk can stretch hundreds. But the Oort Cloud, if it exists as Oort imagined, begins thousands of units away and extends almost 100,000. The space between Neptune's orbit and the beginning of the Oort Cloud is not empty, but it is vast. It is a gulf filled with scattered ice, distant dwarf planets, occasional visitors, and more silence than words can describe. To cross such distances, even in thought, is to confront the limits of imagination. Voyager 2, which passed Neptune in 1989, is still travelling outward more than 30 years later. It has not yet left the heliosphere. It will not reach the inner edge of the Oort Cloud for centuries. This means that even our fastest machines are still children playing near the shoreline, not yet ready to cross the deep ocean beyond. But what makes the region beyond Neptune's shadow so compelling is not just its scale. It is the way it blurs categories. Planets, dwarf planets, asteroids, comets. All these distinctions begin to merge. Out there, icy worlds drift on tilted orbits, neither planets nor comets, some large enough to have atmospheres, others small enough to remain invisible. Some astronomers suspect that a large, undiscovered planet, sometimes called Planet 9, might lurk in this region, its gravity shaping the orbits of distant objects. If it exists, it would be a reminder that even now, with telescopes scanning the skies and satellites mapping the heavens, Our solar system is not fully known. The vastness beyond Neptune hides secrets still waiting to be uncovered. There is also the sense of isolation. The planets, even when distant, form a kind of family. They share a common plane, they orbit in predictable rhythms, they shine with reflected sunlight. But beyond Neptune, that order weakens. Orbits tilt, scatter, stretch. Objects are more solitary, more irregular. It feels like moving from a bustling city into wilderness, from roads and houses into untamed forest. The rules still apply, but the patterns are harder to see. And in that wilderness lies the path to the Oort Cloud, the true outer edge. When astronomers chart these distant regions, they are not just adding dots to a map, they are extending our sense of belonging. Each new dwarf planet discovered, each new scattered object tracked, reminds us that the solar system is larger than we thought. It stretches farther, it holds more, it refuses to end where we once placed a boundary. And in that refusal, it mirrors the way the universe itself behaves. Every time we think we've reached an edge, we discover more beyond it. The vastness beyond Neptune's shadow is also a time capsule. The objects that live there are largely unchanged since the early days of the solar system. Their surfaces record billions of years of history, untouched by warmth, preserved by cold. To study them is to study the past, to hold in our instruments the record of how planets formed, how dust became worlds, how the solar system grew. These objects are not just distant, they are ancient, carrying memories older than any life on Earth, and yet they remain elusive. Even with the best telescopes, most of them are too faint to see. The light they reflect is weak, swallowed by the distance. Many remain undiscovered, hiding in the dark, waiting for a new generation of instruments to find them. The future of astronomy will bring them into view, but for now, they remain part of the mystery, shadows in the chart, reminders of how much lies beyond. As we drift in thought past Neptune through the Kuiper Belt, across the scattered disk, we begin to sense what Oort himself must have felt when he proposed his cloud. That the solar system is not a neat arrangement of planets, but a structure with layers, each more diffuse, each more mysterious, each expanding the boundary of what we call home. Beyond Neptune lies not emptiness but abundance, not an ending but a continuation, not silence but a whisper of more. And as we hold that thought, the path ahead grows clearer. For if the Kuiper Belt and scattered disk are the transition zones, then the Oort Cloud is the true frontier. Beyond Neptune's shadow lies not just the vastness of distance, but the first step toward the edge of reality itself. To picture the Oort Cloud is to imagine the solar system wrapped in a shell, a soft boundary that encases everything familiar. It is not a wall, not a fence, not a hard surface you can touch, but a sphere of scattered ice, trillions of frozen fragments drifting in the deep cold. In this way it resembles a cocoon, a fragile but encompassing layer that separates the inner system from the greater galaxy beyond. The word cocoon suggests protection, a kind of sheltering. When a caterpillar spins a cocoon, it creates a safe space in which transformation can take place. For the solar system, the Oort Cloud functions differently, but it still carries the aura of a boundary, a gentle envelope that defines the space within. It may not shield us from the universe, but it does mark the edge where our star's influence still lingers. The sun's gravity reaches out to hold these icy bodies, keeping them from drifting away completely. Beyond that distance, the galaxy itself takes over, tugging and stirring, shaping orbits in ways that no longer belong to the sun alone. Thinking of it as a cocoon helps us appreciate its scale. From the inner edge, thousands of times farther than Earth from the sun to the outer edge, where a light year of distance may separate a comet from its parent star, the Oort Cloud is almost unimaginably vast. If the Earth were the size of a marble, the cloud would stretch out across the length of a city. Inside that sphere, the planets and moons are like tiny specks near the centre, barely noticeable against the enormity of the surrounding shell. It is humbling to realise that what we think of as the solar system is, in terms of sheer size, only the innermost region of a structure far greater. But a cocoon is also a place of waiting. The icy bodies of the Oort Cloud drift for billions of years, unchanged, untouched, preserved. They are not lifeless in the sense of being irrelevant. They are repositories, time capsules. Their ices contain the chemistry of the early solar system, frozen snapshots of the conditions that prevailed before planets formed. Each one is a bead of memory, suspended in the dark, waiting for the rare event that might send it inward. In that sense, the Oort Cloud is not just a shell, but an archive. It holds the ingredients of beginnings, storing them at the edge of reality for ages to come. The cocoon image also captures the sense of transition. Inside the Oort Cloud lies the solar system, warmed by the sun, structured by its gravity, familiar in its order. Outside lies the galaxy, vast and unpredictable, full of stars drifting past, full of forces that dwarf the reach of our star. The Oort Cloud sits between, not fully one or the other. It is the threshold, the in-between place, where belonging is ambiguous. That ambiguity is part of what makes it so fascinating. It is both inside and outside, both ours and not ours, both part of the solar system and part of the galaxy. To imagine what it would be like to enter the Oort Cloud is to imagine leaving behind the last traces of planetary order. The Kuiper belt and scattered disk, though distant, are still tied to the plane of the planets. Their orbits reflect the structure of the inner system. But in the Oort Cloud, orbits tilt in every direction. Objects surround the sun like stars surround the galaxy, scattered in a sphere. It would be disorienting, like stepping out of a structured landscape into a fog where directions lose meaning. Up, down, sideways. All would blur. The cocoon surrounds equally in every orientation. If you could float among those icy bodies, you would not see a crowd. The distances between objects are immense, so immense that you might drift for years without coming close to another. The cocoon is not dense, not like the silk spun by an insect, but gossamer thin, stretched across light years. Its strength lies not in closeness, but in scale. Trillions of objects, each far apart, but together forming a whole. That whole is the shape of the cocoon, the invisible boundary that encases us. There is another way in which the Oort Cloud feels like a cocoon. For billions of years, the solar system has been evolving, changing, maturing. Planets shifted positions, collisions created moons, asteroids bombarded surfaces, life arose on at least one world. All the while, the Oort Cloud has remained silent, holding its icy fragments in reserve. It is as if the system's transformation has been taking place inside the cocoon, while the cocoon itself endures unchanged. The planets have danced and fought and grown, while the halo has remained a steady backdrop. This endurance matters, because it means the Oort Cloud may be the most ancient, most pristine structure we can imagine. The planets tell stories of change, erosion, volcanism, atmosphere. The Oort Cloud tells a story of stillness. If we could study its comets directly, we would be touching the unaltered past. We would be reaching into the cocoon to recover the seeds from which the solar system grew. The cocoon is not perfectly sealed. From time to time, stars pass close enough to stir its contents. A star drifting within a light year of the sun can perturb orbits, nudging comets inward. The galaxy's tidal forces also act on it, gently shifting objects, causing some to fall toward the inner system. These disturbances are like the small ruptures in a cocoon surface, the places where transformation becomes visible. When a comet appears in our sky, it is the result of such a rupture, a reminder that the cocoon is not static but connected to the larger universe. In thinking of the Oort Cloud this way, it is tempting to see it as fragile, as if it could be torn apart by the galaxy's currents. And yet it has endured for billions of years. The cocoon is resilient, not in its density but in its scale. It is so vast, so diffuse, that disturbances alter it but never destroy it. It persists as a boundary, reshaped but never erased. For us lying here thinking of it, the image of a cocoon carries comfort. It suggests enclosure, a sense of being held. The solar system, with all its complexity, is wrapped in this sphere, cocooned against the immensity of the galaxy. We live not in exposed isolation, but inside a structure, however invisible, that surrounds us. That thought alone can be soothing, a reminder that even at cosmic scales there is a sense of belonging, of being encased within something larger. And yet, the cocoon is also an invitation. Just as a caterpillar eventually emerges transformed, the solar system is not meant to remain enclosed forever. Stars drift, galaxies evolve, orbits shift. The Oort Cloud may one day release not only comets, but entire histories, scattering its contents into the galaxy, mixing them with those of other systems. Perhaps some fragments will fall toward other stars, carrying with them the frozen chemistry of our beginnings. In that way, the cocoon is not just protective but transitional. It holds, but it also lets go. If we think about the future of exploration, the Oort Cloud looms as a goal almost beyond reach. To send a probe to its inner edge would take centuries at our current speeds. To cross it entirely would take tens of thousands of years. And yet, the dream persists. To enter the cocoon, to drift among its icy archives, to hold in our instruments a fragment preserved since the dawn. That is the promise of a future humanity may one day claim. For now it remains only a dream, but a dream that shapes how we think of the solar system. The cocoon reminds us of scale, of patience, of preservation. It is the most distant part of what we can still call ours, yet it belongs to the galaxy as much as to us. It is both cradle and border, archive and threshold, fragile and enduring. If the Oort Cloud is a cocoon, holding us within a sphere of icy fragments, then the space beyond it is something altogether different. Step past that halo, and you leave the solar system behind. What greets you then is not another layer of structure, not another belt of objects, but a vastness unlike anything we know up close. It is the interstellar medium, the space between the stars, a region defined less by what it contains and more by what it does not. It is silence stretched across light years. To imagine that silence, think of the quietest place you have ever stood. Perhaps it was deep in a forest, where the wind held still and no bird sang. Perhaps it was in a room built to absorb sound, where even your own heartbeat seemed loud. Now stretch that quiet beyond all measure. Remove the wind, the rustle of leaves, the hum of insects. Remove the air itself, so there is nothing to carry sound. What remains is not just absence of noise, but absence of the possibility of noise. That is the silence between the stars. But silence does not mean emptiness. The interstellar medium does contain matter, though it is spread thinner than the finest vacuum we can create on Earth. Hydrogen atoms drift here and there, scattered like grains of sand across an ocean. Dust particles, tiny and dark, float through the void, sometimes clumping together to form clouds. Cosmic rays, high-energy particles born of supernovae and other violent events, race through the emptiness at near light speed. Magnetic fields thread through it all, subtle but present, linking regions across vast distances. To call it empty is to overlook the delicacy of what is there. It is not nothingness, but a whisper of something stretched across infinity. For a spacecraft leaving the solar system, crossing into interstellar space is like stepping into this whisper. Voyager 1, the farthest of our probes, has already crossed that boundary. Its instruments recorded the change when solar particles gave way to galactic ones, when the density of plasma shifted, when the influence of the sun's bubble finally yielded to the galaxy. And yet, for all that, the view would not have changed. From a window, there would still be darkness. The stars would look no closer, no brighter. the silence would remain. Boundaries measured by instruments are invisible to the eye. This silence is not oppressive. In its way, it is gentle, patient. Stars are separated by light years, so the space between them is immense. Within that immensity, disturbances are rare. A star explodes, a shock wave ripples through, but then millions of years pass in quiet. The vast majority of interstellar space is calm, a stillness that endures across timescales far beyond our comprehension. It is a stillness that cradles stars, allowing them to form, live, and die without constant interference. From our perspective, the silence between the stars can feel lonely. We're used to proximity, to neighbours, to voices close by. But on cosmic scales, distance is the rule, not the exception. Stars are not crowded together like street lamps, but spread apart like distant villages across a continent. Their light takes years to reach each other, their gravity barely felt beyond their immediate companions. In between lies not a void to fear, but a quiet that sustains. And yet, even in that silence, there is connection. The hydrogen atoms drifting between stars are the raw material from which new stars will one day form. The dust grains carry heavy elements forged in older stars, seeds of future planets and perhaps future life. The magnetic fields guide charged particles, shaping paths across light years. The silence is not sterile but fertile, holding the ingredients of creation, waiting for them to gather. It is a pause between acts, a space of potential. It is also the silence that defines perspective. When you look up at the night sky, the stars you see are separated by this very medium. Each pinprick of light is a sun, surrounded by its own planets, wrapped perhaps in its own Oort Cloud. Between each one lies this same vast quiet, stretching farther than the mind can hold. To contemplate it is to feel both small and connected, both humbled and expanded. The silence between the stars is also a place of travel. Comets that are nudged outward from the Oort Cloud may not fall back inward. Some are given enough velocity to escape the sun entirely, drifting off into interstellar space. Once free, they become wanderers, no longer bound to any star, moving through the silence for millions or billions of years. They may pass near another star, join another system, or drift forever, unseen. In that way, the silence is not empty but full of travellers, tiny icy seeds crossing the galaxy without destination. Perhaps in time, fragments from our solar system will seed another, carrying with them the chemistry of our beginnings. For us, imagining travel into this silence is imagining exile and possibility at once. A spacecraft that could leave the Oort Cloud behind would find no landmarks, no signposts, no up or down. Navigation would depend on stars, distant and unchanged. Communication with Earth would take years, then decades, then centuries, until finally even light itself would take too long to bridge the gap. It would be the truest kind of departure, a step into independence, but it would also be a step into community, for the silence is shared. Every star is surrounded by it. Every system floats within it. Every galaxy is built upon it. There is something soothing in thinking of silence this way, not as absence, but as background, not as loneliness, but as continuity. The silence between the stars is what allows stars to shine distinctly, what allows systems to exist as individual entities, what allows the galaxy to be structured. Without the spaces between, the whole would blur. Silence makes music possible, emptiness makes form visible. In the same way, the silence between stars makes the universe itself coherent. And if you think of silence as a kind of sleep, then interstellar space is the great resting place of the cosmos. Stars flare and burn, comets streak, planets circle, but all of it happens within a backdrop of immense quiet. The drama of creation and destruction is framed by calm. It is the calm that makes the bursts meaningful, the silence that gives the song shape. When you imagine lying at the edge of the Oort Cloud just beyond the cocoon, looking outward, you would see that silent stretch before you. It would not frighten you, because it would not feel hostile. It would feel steady, vast, patient. And in that feeling you might understand why the Oort Cloud feels like an edge of reality. Not because reality ends there, but because beyond it lies a form of reality we are not built to experience directly. A reality of distances so great, of timescales so long, that human senses falter. To step beyond is to step into silence so deep that it becomes another kind of presence. This silence has been there since the galaxy formed. It will be there long after our sun burns out, long after the planets change, long after the Oort Cloud itself disperses. It is the one constant, the one enduring backdrop. And to think of it, as you drift towards sleep, is to find comfort in its steadiness. Because if silence is the medium between stars, then we are never truly without it. It surrounds us, even here on Earth, softened by wind and voices but always waiting underneath. The same silence that holds galaxies holds us too. At the edge of the solar system, in the region where the Oort Cloud thins into interstellar space, one force still lingers, subtle but unbroken. That force is gravity, the gentle grip of the sun extending across unimaginable distances. It is faint, so faint that other stars can tug just as strongly on the icy bodies in the outer cloud, but it is still there. Like the softest thread stretched to its limit, it ties the farthest comets to the solar system, keeping them in orbit even when they are trillions of kilometers away. To appreciate how delicate this grip is, it helps to think of gravity not as something absolute, but as something that diminishes with distance. Close to Earth, gravity is strong enough to hold oceans, mountains, and our bodies to the surface, move outward to the moon, and Earth's pull still holds it, keeping it in orbit, even though the strength is far weaker. The sun exerts its gravity across the whole solar system, keeping the planets circling. But the farther you go, the weaker the pull becomes. By the time you reach the Oort Cloud, the sun's hold is little more than a whisper. It is not the commanding pull that governs Mercury's quick orbit or Jupiter's massive sway. It is instead a quiet suggestion, easily interrupted by passing stars or the tide of the galaxy. And yet, even that whisper matters, because without it, the Oort Cloud would not exist. Those trillions of icy fragments would have drifted away long ago, lost to interstellar space. It is gravity, faint though it is, that maintains the cocoon, that keeps the solar system bound in a sphere. The grip may be gentle, but it is persistent. It holds across billions of years, across gulfs of space so immense they strain imagination. Imagine holding a feather by a single strand of thread, lifting it into the air. The thread is thin, easily broken, but as long as it holds, the feather remains connected to you. The Oort Cloud is like that feather, and the sun's gravity is like the thread. Fragile, perhaps, but enduring. It is astonishing to think that a star 150 million kilometers from us, a distance that already feels incomprehensible, can still exert influence 100,000 times farther out. The math of gravity tells us it should, but the reality is still humbling. This gentle grip also explains why comets can be dislodged. A star passing within a light year of the sun can disturb the balance, its gravity pulling just enough to change an orbit. Galactic tides, the collective pull of the Milky Way's mass, can nudge objects as well. Because the sun's hold is so faint at that distance, it does not take much to upset it. The Oort Cloud is stable on large scales, but individual objects are easily perturbed, and when that happens, when one of those icy bodies is nudged off balance, it begins its long journey inward, becoming one of the comets we see. This interplay, the sun's grip holding, the galaxy's pull stirring, creates a dynamic tension at the edge. The Oort Cloud is not a rigid structure, but a living boundary, shaped by competing forces. Each comet within it feels both the loyalty of the sun and the invitation of the galaxy. Sometimes the loyalty wins, keeping the object in orbit for billions of years. Sometimes the invitation wins, sending it outward into interstellar space. And sometimes the two combine, bending the orbit inward, giving us a cometary visitor. To imagine this balance is to imagine standing at the edge of a shoreline where two tides meet. Waves from one direction push one way, waves from another push the opposite. The water churns, not chaotic, but full of subtle shifts. Objects caught their drift, tugged back and forth, held yet unsettled. That is the experience of an icy body at the edge of the Oort Cloud. It belongs to the sun, but not completely. It belongs to the galaxy, but not fully. It drifts in a liminal zone where gravity is gentle and allegiance is uncertain. This gentle grip also connects us in a way to the galaxy itself, because the sun's pull is not absolute, it blends into the background pull of the Milky Way. At smaller scales, we speak of the solar system as a distinct entity. At larger scales, it is just one participant in the galaxy's dance. The Oort Cloud is where that distinction blurs. It is where the grip of the sun is not enough to isolate us completely, where galactic forces become part of our structure. In this way, the Oort Cloud is a meeting place, a place where local and cosmic overlap. There is a quiet reassurance in this thought, because it reminds us that no system is truly separate. Gravity, faint though it becomes, is universal. It binds stars into galaxies, galaxies into clusters, clusters into cosmic webs. The sun's grip on the Oort Cloud is one strand in a much larger net, connecting us to structures far beyond our immediate home. Even at the edge, even in the gentlest pull, we are part of something larger. Think for a moment about Voyager 1, drifting now beyond the heliopause. It is still bound by the sun's gravity, even though it will never return. Its speed is enough to carry it outward forever, but technically it is still connected. It is like a bead sliding along a thread, moving farther and farther but not escaping the pull completely. That image captures the paradox of the edge. You can leave, but you're never entirely unbound. Gravity does not let go, it only grows weaker. The gentle grip also raises questions about identity. If the Oort Cloud is held so loosely, is it really part of the solar system, or is it already part of interstellar space? The answer is not clear, and perhaps it does not need to be, because identity at the edge is not about boundaries but about relationships. The Oort Cloud exists because of the relationship between the sun's gravity and the galaxy's pull. It is both solar and galactic, both ours and not ours. That duality is part of its essence, and yet, even in its faintness, the sun's grip shapes destinies. The comets that fall inward, the icy bodies that wander into the warmth of the inner system, do so because of orbits held in place for eons. Without gravity, there would be no comets, no reminders of the halo, no evidence of the edge. The spectacle we see in the sky begins with a force almost too small to imagine, stretched across light years, holding just enough to matter. Perhaps that is the deeper lesson of gravity's gentle grip, that even the faintest forces given enough time and distance can shape worlds. We think of power as something strong, immediate, overwhelming. But the Oort Cloud reminds us that endurance is its own kind of strength. A grip that lasts for billions of years, across 100,000 astronomical units, is powerful precisely because it is patient. It does not need to overwhelm, it only needs to persist. As you picture this, lying back with the image in your mind, imagine the trillions of icy bodies drifting in their vast orbits, each one a bead on a thread. Some are tugged slightly this way, some that way, but most remain bound, generation after generation, held in place by a grip too faint to feel, but too steady to ignore. And in that holding, they become part of the structure, part of the cocoon, part of the edge. When we speak of the solar system having an edge, we imagine a line, a boundary that separates the inside from the outside. We picture something clear, like the border of a country on a map, or the shore where land ends and water begins. But the more we follow the pull of gravity outward, the more we realise that such lines are illusions. The sun's grip weakens but never disappears. The Oort Cloud blurs into the galaxy. Even the silence beyond is not truly empty, but part of a continuum. And so the question rises, is there truly an edge to reality, or is every edge only something we invent to make sense of the vastness? Edges comfort us. They give us categories, divisions, places to stand. On Earth, edges are everywhere. The coastline marks the meeting of land and sea. The horizon marks the limit of our sight. The walls of our rooms define the spaces we inhabit. We're used to clear boundaries, and we extend that habit into the cosmos. We want to know where the solar system ends, where the galaxy begins, where the universe itself has borders. Yet the cosmos resists such clarity. Every time we think we've drawn the line dissolves into gradation. Take the atmosphere of Earth. Where does it end? We give names to its layers: troposphere, stratosphere, mesosphere, and we place limits at certain altitudes, but the air only becomes thinner, until eventually it fades into space. There is no single altitude where one can say, definitively, here the atmosphere stops. It is a transition, not a wall. The same is true of the solar system, the heliosphere, the Oort Cloud, the galaxy's pull. Each is a gradient, not an absolute. And what of the universe itself? Cosmology tells us it may be infinite without boundary at all, or it may be finite but unbounded, curved back on itself like the surface of a sphere. In such a universe, to travel forever in one direction would eventually bring you back to where you started. In either case, the idea of an edge loses meaning. If space is infinite, there is no end. If space is finite but unbounded, then the edge is only the illusion of perspective. Why then do we cling to the idea of edges? Perhaps because our senses evolved to navigate finite spaces. We live in environments where walls matter, where cliffs matter, where the line between forest and field can mean the difference between shelter and exposure. Boundaries have survival value. They anchor us. To live without them would feel disorienting, so we impose them on the universe, even where they do not exist. We draw edges on maps of the cosmos because we are edge-making creatures. But when we let go of that habit, something shifts. To imagine reality without edges is to imagine connection. If there is no absolute boundary between the solar system and the galaxy, then we are not isolated. We are part of a continuum, part of a web of influences that stretch outward without end. The Oort Cloud is not the end of the solar system, but a region where solar and galactic forces mingle. The galaxy itself is not an isolated island, but part of a cluster, which in turn belongs to a supercluster and so on, up to the filaments of the cosmic web. Each so-called edge is only a transition zone. This thought can be unsettling at first. To live without edges is to live without certainty, without the comfort of saying, here I belong, there I do not. But it can also be freeing. Because if there are no hard edges, then belonging is not limited. We belong not only to Earth, not only to the solar system, but to the galaxy, the universe, the whole continuum of existence. Boundaries dissolve, and in their place is participation. The question of edges is not only scientific but philosophical. For centuries, thinkers have debated whether reality itself has limits. Does time have a beginning and an end? Does space stretch forever or curve back upon itself? These questions do not admit simple answers. Even today, with telescopes peering billions of light years outward, we cannot say what lies beyond. Perhaps there is no beyond. Perhaps the question itself is flawed. But in another sense, edges are always with us. Because as finite beings, we encounter limits everywhere. The limit of how far we can see, how far we can travel, how long we can live. Each of us has an edge, defined not by the universe but by our bodies, our lifespans, our capacities. These edges are real to us, even if reality itself is boundless. And so when we ask whether there is an edge to the solar system or to reality, we're also asking about ourselves. Where do we end and where does the world begin? Think again of gravity's gentle grip. At the edge of the Oort Cloud, the sun's pull is faint, but not absent. Another star's pull may be equally strong, but the comet is still bound, still connected. The comet's identity is not tied to a single centre, but to the interplay of multiple forces. Perhaps we are the same. We are not bounded by hard edges, but shaped by relationships. We belong to families, to communities, to species, to ecosystems. Each belonging fades into another, not sharply, but gradually. In this way, the Oort Cloud becomes more than a structure. It becomes a metaphor for reality itself, not a closed system with walls, but a continuum of influences stretching outward. Not an edge, but a cocoon of transitions. The comets are not trapped, but neither are they free. They exist in the in-between, held by multiple pulls at once. So do we. The idea that there may be no edge to reality can feel dizzying, but it can also feel restful, because if there are no walls, then there is no final enclosure. The universe is not a box with sides, but an openness. This silence between the stars is not a void to fear, but a medium in which everything participates. The edge we imagine may only be the limit of our perspective, not the limit of reality itself. And yet, edges will always matter to us, because they are part of how we experience the world. When a comet falls inward, we see it cross edges, from the dark to the light, from invisibility to spectacle, from silence to story. When Voyager crossed the heliopause, we marked it as a milestone, even though the view outside did not change. Edges help us mark transitions, even if reality does not contain them in the way we imagine. They are tools for storytelling, for orientation, for meaning. So perhaps the answer is both. Perhaps there is no true edge to reality, and yet we will always draw them. We will always look outward and ask, where does it end? And in the asking, we will always learn more about ourselves. The edge is not out there. It is within us, in our need for boundaries, our longing for definition. When you lie back and think of the Oort Cloud, you may picture it as the edge of the solar system, and in one sense that is true. It is where the sun's influence fades into the galaxies, but in another sense it is not an edge at all. It is only another gradient, another transition, another place where belonging changes shade but does not vanish. To imagine it is to confront the illusion of edges and to see that reality may be more seamless than we can comprehend. And as that thought settles, another rises. If there is no true edge, then what lies beyond is not separate from us. It is part of the same continuum, the same reality, stretching outward without end. The question is not where it stops, but how far we are able to follow. When we imagine the solar system, we think of planets orbiting, moons circling, comets wandering, and the sun at the centre holding it all together. But there is another presence, less visible, always flowing, filling every corner of space inside the system. That presence is the solar wind, a constant stream of charged particles racing outward from the sun in every direction. It is not wind as we know it on Earth, not air rushing across a landscape, but a river of electrons and protons, carrying with it the magnetic field of the star that gave us life. This wind begins deep within the sun, where temperatures and pressures are so extreme that atoms are stripped of their electrons, forming plasma. From there, the plasma pushes outward, carrying energy and matter into space. It streams past the planets, creating auroras when it brushes Earth's magnetic field, sculpting tails of comets as they fall inward, filling the solar system with an invisible presence. Though we cannot see it directly, its effects shape everything. The solar wind travels at hundreds of kilometers per second, fast enough to cross the space from the sun to Earth in just a few days. By the time it reaches the outer planets, it has thinned, but it is still flowing, and it does not stop at Neptune or even at Pluto. It continues outward, past the Kuiper belt, until eventually it encounters resistance. That resistance is the interstellar medium, the gas and plasma that fills the galaxy. Where the solar wind meets the galaxy's own breath, a boundary forms. That boundary is called the heliopause. The heliopause is not a wall. It is not a hard surface. It is a transition, a zone where the pressure of the solar wind balances against the pressure of the interstellar medium. Inside, the particles come mostly from the sun. Outside, they come mostly from the galaxy. It is the place where the sun's breath ends and the galaxy's begins. To cross it is to move from one environment into another, from the familiar space of our system into the broader space of the Milky Way. In 2012, Voyager 1 became the first spacecraft to cross this boundary. Its instruments recorded the change. The density of particles shifted. The magnetic field altered. The solar wind no longer dominated. Voyager had left the sun's bubble and entered interstellar space. It was a historic moment, a milestone not just for a spacecraft but for our species. For the first time, something built by human hands had crossed into the space between stars. Yet the irony is that the view outside the spacecraft would not have changed. If you were on board, looking out a window, you would still see darkness, stars scattered across the black, the sun a distant point. The edge was not visible. It was measurable but not experiential. That is the paradox of boundaries in space. They are real, but they are subtle. To think of the heliopause is to think of breathing. The sun exhales its plasma endlessly, filling the space around it. The galaxy exhales as well, filling the wider medium. At the heliopause, these two breaths meet, pressing against each other, shaping a boundary that is always in motion. The solar wind expands and contracts with the sun's cycles of activity, pushing the heliopause outward during solar maximum, letting it shrink inward during solar minimum. The boundary is not fixed but alive, shifting with the rhythm of the star. This shifting matters, because it means the edge of the solar system is not static. It breathes, it pulses with the activity of the sun, with the waves of the galaxy. The heliopause is not a line drawn once and for all, but a dynamic frontier. To imagine it is to imagine a bubble, flexible, stretching and shrinking, always balancing the pressures on either side. Inside that bubble, we live. Outside, the galaxy waits. The concept of a bubble may seem fragile, but it is also protective. The heliosphere, the region dominated by the solar wind, shields us from some of the cosmic rays that race through interstellar space. Without it, the Earth would be bombarded by even more high-energy particles than it already is. The bubble is not a shield in the sense of a wall, but it is a filter, softening the galaxy's harshness, giving our world a gentler environment in which life can thrive. In that sense, the sun's breath is not only a force, but a gift, shaping the conditions that allowed us to exist. And yet, as with every boundary, the heliopause reminds us of connection. Because beyond it, the galaxy's breath flows in. The solar system is not isolated, but porous, touched by the larger currents of the Milky Way. The solar wind and the interstellar medium are not enemies, but partners, each shaping the other, each part of a larger balance. To think of them is to realize that the solar system is not a closed container, but a participant in the galaxy's larger flow. It is tempting to picture the heliopause as the edge of our world, the point where we leave home. But in truth, it is just one of many transitions. Beyond it lies the Oort Cloud, still bound to the sun's gravity. Beyond that lies the galaxy itself. Each boundary is both real and not real, both measurable and invisible. The solar wind meets the galaxy, but the sun's influence still extends. The galaxy breathes around us, but we remain distinct. The edge is a conversation, not a wall. When you imagine drifting outward, past the planets, past the Kuiper belt, past the scattered disk, and finally reaching the heliopause, you might picture a subtle shift. Inside, the particles around you mostly trace back to the Sun. Outside, they mostly trace back to supernovae, to other stars, to the collective breath of the galaxy. It would not look different, but if you could sense the particles themselves, you would feel the change, like stepping from one climate into another. The air is gone, but the analogy remains. It is a change in atmosphere, a change in source, a change in belonging. For humanity, the crossing of the heliopause by Voyager was more than a technical achievement. It was a symbolic moment. It told us that our creations could leave the sun's breath behind, that we could extend ourselves into the galaxy. Even though Voyager will never reach another star, its presence in interstellar space is a marker. It shows that we are capable of reaching the boundary and crossing it. The spacecraft carries with it the golden record, a message to anyone who might one day find it. Music, greetings, images of life on Earth, all carried beyond the solar wind into the galaxy's domain. In that gesture, the boundary became not just a scientific frontier but a cultural one, a place where humanity extended its voice outward. There is a quiet poetry in thinking of the heliopause as a meeting of breaths. The sun breathes out, the galaxy breathes in, and at their balance point a frontier forms. It is not hostile, it is not abrupt. It is a blending, a negotiation, a constant dialogue. To rest in that image is to feel the calm of continuity. Because if even the edge of the solar system is not a wall but a conversation, then perhaps reality itself is always conversation, always blending, always shared. As you let that thought settle, you might notice how it connects back to everything we have considered. The Oort Cloud as a cocoon, the silence between the stars, gravity's gentle grip, all are part of this larger truth, that edges are not ends, they are gradients, balances, places where one influence fades and another rises. The heliopause is one such place, the meeting point of solar wind and galactic breath, and beyond it, the journey continues. Every so often, the quiet of the solar system is interrupted by something unexpected. A body appears that does not belong to our family of planets, moons or comets. Its orbit is not bound to the sun in the same way. Its path cuts through like a stranger passing through town, a traveller with no intention of staying. These are the interstellar visitors, objects born around other stars or perhaps in the spaces between them, now crossing our system before slipping away again. The first time humanity recognised such a visitor was in 2017, when telescopes detected a faint elongated object moving faster than anything bound to the sun. It was named Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. The name was chosen carefully, for the object truly was a messenger, though its message remains mysterious. Unlike any comet or asteroid we had seen, Oumuamua showed no visible coma, no tail of gas or dust. Its shape appeared elongated, perhaps cigar-like, perhaps flat like a pancake, though observations were too brief to be sure. It spun in a tumbling motion, reflecting sunlight in a way that made its brightness flicker. And most striking of all, its orbit was hyperbolic, meaning it was not bound to the sun at all. It had come from interstellar space, passed through, and would leave forever. For weeks, astronomers studied it, measuring its path, searching for signs of outgassing that might explain its slight acceleration as it passed. No clear answers came. Some proposed it was a fragment of a disrupted comet, its volatile materials hidden beneath a crust. Others wondered if it was something stranger, a shard of a shattered planet, or even, in more speculative corners, a relic of alien technology. The debates continue, but the truth remains elusive. By the time we realised what Oumuamua was, it was already too far and too faint to study closely. It slipped away, leaving more questions than answers. 2 years later, in 2019, another interstellar visitor arrived. This one was a comet, visible with a coma and tail, unmistakably icy. It was named Borisov, after the amateur astronomer Gennady Borisov who discovered it. Unlike Oumuamua, Comet Borisov looked more familiar, though its hyperbolic orbit confirmed it too was not bound to the Sun. It came from beyond, a comet born in another star system now passing through ours. For months, astronomers studied it, measuring its composition, noting similarities and differences with comets of our own. In the end, Borisov seemed ordinary in its chemistry, a reminder that the processes that form comets may be universal. Together, Oumuamua and Borisov opened a new field of astronomy. For centuries we had studied the bodies of our solar system. Suddenly we had glimpses of material from beyond, messengers carrying the imprint of other worlds. They showed us that the solar system is not isolated but part of a larger flow, where objects are exchanged, where fragments cross the gulf between stars. These visitors also hint at something deeper. If fragments from other systems can reach us, then fragments from our system must reach others. Every time a comet in the Oort Cloud is nudged with enough energy, it may escape the Sun's gravity entirely, drifting off into the galaxy. Over billions of years, trillions of such fragments may have been launched, each carrying with it the chemistry of the early solar system. Perhaps some have fallen into other systems, colliding with planets, delivering water or organics. Perhaps some have been captured, becoming comets around other stars. In this way, systems share with one another. The galaxy is not a set of isolated islands, but an archipelago connected by travellers. To imagine this is to picture a cosmic migration, tiny icy bodies drifting through interstellar space, some for millions of years, some for billions, until at last they encounter another star's gravity. Most pass through quickly, like Oumuamua. Some linger longer, like Borisov. A few may be captured, settling into new orbits, becoming part of a new family. Over time, this migration blurs the edges of systems. It means that what we call ours may not be purely ours, and what we see as theirs may not be purely theirs. Reality, again, resists hard borders. These visitors also change our perspective on possibility. If material can cross from one system to another, then so can the ingredients of life. Panspermia, the idea that life or its precursors can spread between stars, gains plausibility in this context. Perhaps comets like Borisov carry not only ice and dust but amino acids, complex molecules, seeds of potential. If such seeds fall on a hospitable world, could they spark biology? The thought is speculative, but it underscores how interstellar visitors expand our sense of connection. Life may not arise in isolation but in networks, nourished by exchanges across light years. At the same time, interstellar visitors remind us of how much we cannot control. They arrive unannounced, their paths unpredictable until we spot them. By the time we detect them, they are already rushing through too fast for us to catch. They are glimpses, not possessions. To truly study one up close would require missions ready to launch within days, spacecraft capable of chasing objects at extraordinary speeds. Someday we may achieve this. For now, we can only watch as they pass. There is something humbling in this. We live in a solar system we think of as vast, but it is only one among billions. To see objects from beyond is to be reminded that the galaxy is full of activity, full of exchanges, full of travellers we will never know. We are not alone in being a source of comets. Every star may be surrounded by its own Oort Cloud, its own halo of icy fragments, and from each one, comets may escape, drifting across the galaxy, crossing into other systems. The galaxy may be full of such crossings, constant and unseen. From a quiet, sleepward perspective, there is comfort in this thought, because it means that the edges we draw, between stars, between systems, between us and the galaxy, are softer than they appear. Material flows back and forth. Boundaries are porous. We are not an isolated household, but part of a neighbourhood, a community, a network of exchanges. Even as we lie here imagining silence, the galaxy hums with this slow commerce, fragments drifting like invisible ships between harbours. And perhaps that is why the appearance of Oumuamua captured such imagination. It was not just a rock tumbling through space, it was proof, visible proof that the galaxy is connected. It was a reminder that reality does not stop at the edge of our system. It continues outward, and sometimes it comes to us, uninvited but welcome. As you let that thought rest, imagine the solar system as a house with an open door. Most of the time we see only our own rooms, our own familiar furniture. But now and then, a stranger walks through, glances around and moves on. They do not stay, but their presence reminds us that the house is not alone, that there is a street outside, a city, a world. Oumuamua and Borisov were such reminders, and in the centuries to come there will be more. Instruments will grow sharper, surveys wider, detections more common. The strangers will no longer be so rare. We will begin to recognise them, to learn from them, perhaps even to greet them. For now, though, they remain fleeting. They come without warning, they leave without farewell. They pass through our night skies like whispers, like dreams, like messages half heard, and in their fleetingness lies their power. They remind us of scale, of connection, of mystery. They remind us that the Oort Cloud is not the only edge, that reality extends beyond, that the galaxy is alive with movement. For as long as people have looked up at the night sky, we have seen more than points of light. We have seen stories, omens, gods, monsters, heroes, and signs. The stars have been a canvas, and comets especially have been painted with significance. Long before the idea of the Oort Cloud was born, long before Jan Oort himself traced cometary paths with mathematics, these icy wanderers were already part of human imagination. To us they were not just objects of ice and dust. They were messengers, warnings, promises, mysteries. In the absence of instruments, the night sky was the most reliable calendar our ancestors had. The regularity of the moon, the predictability of planets, the unchanging constellations. All of these brought a sense of stability, but then suddenly, unpredictably, a comet would appear. A glowing streak, sometimes with a tail that stretched across much of the sky, blazing brighter than familiar stars. It was unexpected, impossible to ignore. In cultures across the world, this suddenness gave comets an aura of disruption. Something so bright, so new, so unaccounted for, could not simply be natural. It had to mean something. In ancient China, comets were carefully recorded. Dynastic chronicles describe their appearance in detail, linking them to events on Earth. A bright comet might be seen as a warning of political upheaval, the fall of an emperor, or the rise of a new dynasty. In some cases, the very shape of the comet's tail was interpreted as a clue. A long, sharp tail might foretell war, while a shorter, rounded one might suggest peace. The sky was a mirror of human affairs, and comets were part of that mirror. In Europe, comets often carried darker meanings. They were seen as harbingers of plague, famine, or disaster. The Bayeux Tapestry, an embroidered record of the Norman conquest of England, includes a depiction of Halley's comet blazing in the sky in 1066, interpreted at the time as an omen of the great change that was about to unfold. To people living under uncertain skies with little control over disease or war, a comet's sudden brilliance was too powerful not to be taken as a sign. But not all cultures saw comets as negative. In some traditions, they were thought to be the brushes of celestial beings, painting the sky with streaks of light. In others, they were seen as visitors from the spirit world passing between realms. The unpredictability of comets made them mysterious, but mystery does not always breed fear. Sometimes it breeds reverence, curiosity, or awe. Even today, echoes of these myths linger. When a bright comet appears, newspapers and social media brim with both wonder and unease. The scientific explanation that a comet is simply a fragment of ice and rock heated by the sun is true, but it does not erase the deeper, older feelings they evoke. To see a comet is still to feel touched by something rare, something fleeting, something that interrupts the ordinary. Science gives us the mechanics, but but the imagination supplies the meaning. The Oort Cloud, though invisible, carries this imaginative weight as well. It is not part of ancient myth in name, because it was only proposed in the 20th century, but in spirit it fulfills the same role. It is a hidden realm at the edge of reality, a place of mystery from which comets emerge. If comets are messengers, then the Oort Cloud is their hidden homeland, the source of their journeys, the unseen realm that sends them forth. In mythology, such realms are common. Hidden lands at the edge of the world, places from which heroes come or to which they must travel. The Oort Cloud is a modern echo of those myths, a scientific counterpart to the lands of shadow and wonder our ancestors imagined. Consider how many stories describe thresholds. In Greek myth, there is the river Styx, the boundary between the world of the living and the world of the dead. In Norse tales, there is Bifrost, the rainbow bridge between Midgard and Asgard. In countless traditions, there are gates, walls, oceans or mountains that separate the known from the unknown. The Oort Cloud functions in the same symbolic way. It is the threshold of the solar system, the boundary beyond which lies the greater unknown of the galaxy. To cross it is to leave home, to enter mystery. And just as mythic thresholds often guard treasures or dangers, the Oort Cloud may hold both. Treasures, in the form of pristine fragments from the dawn of the solar system, untouched for billions of years. Dangers, in the form of comets that might one day cross Earth's orbit. The dual nature of comets, givers of water, bringers of life, yet also potential agents of destruction, mirrors the duality of mythic forces. In stories, the gods give and take. In reality, the cosmos does the same. When we describe the Oort Cloud as a cocoon, as a halo, as a sphere of icy fragments, we're using metaphors not unlike those of mythology. We give it shape and meaning, even though we cannot see it directly. It becomes not just a scientific hypothesis, but a symbol, a reminder that the universe still holds hidden realms. It satisfies a human need as old as storytelling itself, the need to imagine borders that contain mysteries, places beyond which lie unknown truths. The Oort Cloud also fits into a larger pattern of human imagination, the tendency to place mystery at the edges. In medieval maps, unexplored regions were marked with phrases like, "Here be dragons." In ancient tales, the farthest oceans hid islands of wonder. Today, the edges of the solar system serve that role. They are where we place the unknown, where we imagine what lies beyond. The Oort Cloud, sitting at that edge, is our modern, dragon-haunted sea. We do not fear literal monsters, but we fill the space with comets, with questions, with symbols of change. Even science fiction has embraced this. Writers imagine civilizations hiding in the Oort Cloud, fleets of ships cloaked in its darkness, alien probes drifting among its icy fragments. The very remoteness of the cloud makes it a fertile setting for imagination. Because if something wanted to hide, where better than a sphere of invisible bodies so distant we cannot see them? Fiction builds on this possibility, turning the Oort Cloud into a stage for human hopes and fears. At the same time, the Oort Cloud has inspired more poetic visions. Some see it as a cradle, holding comets like seeds, waiting to be scattered across the galaxy. Others see it as a mirror, reflecting our need to assign meaning to what we cannot observe. In this way, it is both science and myth, both reality and story. It bridges the two, reminding us that the line between explanation and imagination is itself porous. And perhaps that is why it resonates so strongly. Because the Oort Cloud is not simply a collection of icy fragments. It is a space onto which we project our oldest instincts. To wonder about it is to do what humans have always done, to look into the dark and fill it with meaning. To see comets blazing across the sky and ask, what message do they carry? To draw connections between distant objects and the rhythms of our lives. To feel awe, to feel curiosity, to feel that we are part of a larger story. As you think about this, lying quietly, it may be worth remembering that myth and science are not enemies. There are two ways of approaching the same mystery. Science asks how, myth asks why. Science measures orbits, myth tells stories. Both are attempts to make sense of what we see, to weave meaning from the sky. The Oort Cloud, invisible yet accepted, is a perfect meeting place for the two. It exists in equations and in imagination, in data and in dreams. And as comets continue to arrive, as visitors from that hidden realm, the myth will continue as well. People will still look up and feel awe. They will still wonder what it means. The explanations may grow sharper, but the mystery will never fully vanish. Because the night sky, at its deepest level, is not just a collection of objects, it is a mirror of ourselves. And the Oort Cloud, sitting at the edge, is one more surface in which we see both reality and imagination reflected. For as long as humans have looked into the sky, the question has lingered. Could we go there? Not just in thought, not just with imagination, but with our bodies, our machines, our presence. The moon once felt impossibly far, yet we walked on it. Mars feels distant now, yet plans are already unfolding. But what about the Oort Cloud? What about the edge of the solar system, that cocoon of icy fragments lying tens of thousands of times farther from us than the Earth is from the Sun? Could we ever travel so far? The numbers alone make the challenge staggering. The inner edge of the Oort Cloud is thought to begin perhaps 2,000 astronomical units from the Sun. One astronomical unit, or AU, is the distance from Earth to the Sun, about 150 million kilometers, so we are speaking of 2,000 times that distance, or 300 billion kilometers, just to reach the beginning. The outer edge may extend to 100,000 AU, nearly a light year. Voyager 1, our farthest probe, has been travelling since 1977. It has crossed into interstellar space, but in over 4 decades it has covered only about 160 AU. At that pace, it would take thousands of years to reach the inner Oort Cloud, tens of thousands to cross it, and Voyager is one of the fastest objects we have ever launched. To send humans, or even a mission designed to study the Oort Cloud directly, would require technologies far beyond anything we have built so far. Faster propulsion, better endurance, ways to sustain instruments, or perhaps even crews, over timescales that stretch across generations. The Oort Cloud is not just far. It is a reminder of the scale of the cosmos, the gap between human ambition and cosmic distance. But human history shows that distance alone rarely stops curiosity. We build what once seemed impossible. Airplanes, rockets, satellites, interplanetary probes, all were once unthinkable. Could the same be true for interstellar, or at least inter-Oort Cloud travel? Scientists and engineers have imagined several possibilities. One is nuclear propulsion. Rockets powered not by chemical fuel, which is heavy and inefficient for such long journeys, but by the immense energy of nuclear reactions. Concepts like nuclear pulse propulsion, which would use controlled explosions of nuclear devices to push a spacecraft forward, have been studied since the 1960s. Such technology, if developed safely, could accelerate probes to speeds much higher than Voyager's. Another is fusion propulsion, harnessing the same reaction that powers the Sun. If controlled fusion becomes practical, it could allow spacecraft to reach nearby stars in a few centuries, and the Oort Cloud in far less. Another idea is solar sails, giant reflective sheets pushed by the light of the Sun or by powerful lasers fired from Earth. Such sails require no fuel, only the steady pressure of photons. Though the acceleration is slow, it continues indefinitely, allowing speeds that could eventually surpass chemical rockets. A probe equipped with a solar sail, launched toward the outer system, might in time glide into the Oort Cloud, light pushing it gently outward across the void. Then there is the idea of long-duration missions not meant to be fast but to be patient. probes that drift slowly, powered by small, steady engines, carrying instruments that can last for centuries. They would not bring quick results, but they would embody persistence. Launched in one generation, they might arrive many generations later, sending back signals to descendants who may scarcely remember their beginning. In that sense, they would be like comets themselves, patient travellers whose journeys outlast human lifespans. But perhaps the most fascinating ideas are those that stretch imagination beyond conventional engineering. Concepts like warp drives, bending space itself to shorten distances, or wormholes, theoretical shortcuts through space-time. These remain in the realm of speculation, their physics uncertain, their engineering unimaginable. And yet they capture something important, the recognition that if we are to travel such distances, we may need to think in ways that break beyond our current boundaries. Even if such technologies remain distant, the question itself matters. Because to ask whether we could ever travel so far is also to ask what kind of species we want to be. Do we remain close to home, content with the inner system? Or do we imagine futures where we reach into the outermost regions, into the cocoon, into the galaxy itself? The Oort Cloud may be too far for us today, but it embodies the horizon of possibility. It is the next great beyond. For many, the timescales involved make the idea almost irrelevant. Why imagine journeys that would take thousands of years when human history itself has only stretched a few thousand? But there is another way to think about it. Even if we never send crews, even if we never build generation ships, we might still send machines, emissaries designed to endure. Voyager was not built to last forever, but it has endured far longer than planned. Instruments have failed, power is fading, but it still speaks to us nearly half a century later from interstellar space. If such a probe can last decades, perhaps future ones can last centuries. If they can last centuries, perhaps millennia are possible. With patience, even the Oort Cloud becomes reachable. There is also the symbolic power of imagining such journeys. To think of travelling to the Oort Cloud is to stretch imagination to the limits. It is to confront distance in its most humbling form. It reminds us that the universe is larger than our lives, larger than our civilizations, larger even than our species. And yet, it also reminds us that curiosity is larger still. We may never walk on a comet in the Oort Cloud, but we can imagine it, and in imagining it, we extend ourselves. Picture for a moment what it would be like to arrive, to drift up to an icy body orbiting at the edge of the sun's influence, the sun itself a faint star in the distance, indistinguishable from thousands of others, to land on its surface, crunching down on ice that has been frozen since the dawn of the solar system, to dig into it and hold material that has never been warmed, never been altered, preserved for billions of years. The silence would be complete, the sky would be filled with stars, the Milky Way stretching in luminous arcs. You would know that you were still within the solar system, but only just. Beyond was the galaxy itself, the edge and the threshold. Whether or not we ever reach it, the Oort Cloud gives us something vital: perspective. It shows us what is possible to imagine, even if not yet possible to do. It stretches our sense of distance, of time, of scale. It forces us to think beyond our own lifespans, beyond our own planet, beyond our own century. It challenges us to see ourselves as part of a story that continues, one that may include journeys into the cocoon, into the silence, into the galaxy. And in that way, the question, could we ever travel so far, becomes less about technology and more about identity. It becomes a mirror. What kind of explorers are we? What kind of dreamers are we? What kind of participants in the universe are we? The Oort Cloud does not demand an answer, but it invites one. And perhaps the invitation itself is the most important part. When we imagine the Oort Cloud, It is easy to think of it as distant, abstract, and edge too far away to matter. But what if we turn the perspective around? What if we think of it not only as a boundary, but as a vault, a time capsule that has been quietly holding on to the earliest chapters of the solar system's story? In that light, the Oort Cloud becomes more than an edge. It becomes an archive of creation itself. Consider how worlds are formed. 4.5 billion years ago, the solar system was a swirling disk of gas and dust circling the newborn sun. Within that disk, particles clumped together, grains becoming pebbles, pebbles becoming planetesimals, planetesimals becoming planets. But not all material joined the great building project. Some was thrown outward by gravitational encounters, flung beyond the orbits of the giants, scattered so far that it never returned. And yet, it did not vanish. It remained under the sun's faint influence, settling into vast orbits. These fragments became the seeds of the Oort Cloud. That means the Oort Cloud holds the leftovers of creation, preserved in deep freeze for billions of years. Unlike planets, which evolved, changed, erupted, and weathered, the icy bodies of the Oort Cloud have remained untouched. No volcanic activity reshaped them. No atmosphere eroded them. No tectonic forces shifted their surfaces. They are as close as we can imagine to the original ingredients, frozen snapshots of the early solar system, stored far from the warmth of the sun. To hold such an object in your hands, if such a thing were possible, would be to hold time itself. The water ice within it might be the same water that once filled the ancient disk, the same water that would later rain onto Earth's surface. The organic molecules frozen inside might be the same molecules that seeded the chemistry of life. Every grain of dust, every trapped volatile, would be a page from the first chapters of the solar story, preserved in perfect stillness. This makes the Oort Cloud not only a region of interest, but a treasure chest of history. Scientists long to study comets precisely because they are fragments from this vault. Each comet that falls inward is a courier from the archive, delivering a sample of the past. When spacecraft have flown by comets, like Giotto at Halley's Comet, or Rosetta at Comet 67P, they have tasted these ancient materials, finding carbon compounds, water, and dust older than Earth itself. These comets are the emissaries of the time capsule, carrying to us pieces of what the Oort Cloud has been preserving. It is extraordinary to realise that Earth itself may owe much of its habitability to these frozen archives. Some theories suggest that a portion of Earth's water was delivered by comets long ago during a period when impacts were frequent. If true, then the oceans themselves are gifts from the Oort Cloud's fragments. Without those gifts, life as we know it may never have emerged. In that sense, the Oort Cloud is not just an archive of the past, but a participant in our existence. It stored water and organics until the time came to deliver them. It shaped the conditions of our planet without ever being seen. And yet this archive is incomplete in our knowledge. We have only glimpsed it indirectly, through the comets that enter the inner system. Most of its contents remain hidden, unstudied, unreached. It is as if we have only read a few pages from a vast book, glimpsing hints of the whole but not the full narrative. What lies in the untouched billions of fragments? What chemistries are frozen within them? What stories of early collisions, of formation, of cosmic mixing are written there in ice and dust? The questions are as vast as the cloud itself. Thinking of the Oort Cloud as a time capsule also changes how we view its fragility. These icy bodies are small, loosely bound, easily perturbed. A passing star or the galaxy's tides can scatter them, sending them drifting into interstellar space. In time, the Oort Cloud itself may dissolve, its archive dispersed. If so, then we live in a privileged moment, when the capsule still exists, still surrounds us, still holds its story intact. Millions or billions of years from now, the archive may be gone, its pages scattered across the galaxy. The chance to study it belongs to our era, fleeting compared to cosmic timescales. There is another layer to the metaphor. A time capsule is not only about the past, it is also a message to the future. When people bury time capsules on Earth, they are sending fragments of the present into tomorrow, hoping someone will open them and learn what life was like. The Oort Cloud functions the same way. It is a message from the early solar system to whatever future intelligence might study it. Whether that intelligence is human, a descendant of humanity, or even another species altogether, the message waits, silent and frozen, until someone reads it. To imagine such a future is to stretch thought beyond our lifespans. Picture a civilization thousands of years from now, with ships capable of reaching the Oort Cloud easily. They might mine its comets, study their chemistry, reconstruct the history of the solar system in exquisite detail. For them, the Oort Cloud would not be distant myth, but nearby archive, accessible and familiar. They would see what we only dream of, the unaltered fragments of creation, the pristine time capsules that tell the story of beginnings. And yet, even for us now, the Oort Cloud is meaningful as metaphor. To know it exists, or at least to believe strongly in its existence, is to know that the past is not lost. It is preserved, waiting. The story of the solar system's creation is not buried beyond recall, but stored in icy fragments, ready to be studied. That knowledge itself is a kind of comfort. It tells us that even in the vastness, memory endures. From a human perspective, there is something deeply resonant in this. We build our own archives, libraries, museums, digital records. We keep diaries, photographs, recordings. We preserve fragments of our lives for the future. The Oort Cloud is nature's version of this impulse. It is the universe itself keeping a record, saving pieces of the beginning so they can be read later. In that sense, it mirrors us, or perhaps we mirror it. Both humanity and the cosmos keep time capsules, reminders of where we came from. As you let this thought settle, imagine drifting in the silence of the Oort Cloud, surrounded by invisible comets, each one a page from a frozen book. You cannot see them, but they are there, trillions of them, spread across light years. Each one holds a story billions of years old, a story of how dust became ice, how ice became comets, how comets became part of planets. Together they form an archive that stretches farther than the mind can hold. And within that archive lies the story of us, because without it, we may not exist. And so the Oort Cloud is not only a boundary, it is not only a cocoon, it is also a time capsule, preserving the memory of creation, holding it in silence until we are ready to listen. Whether we ever reach it or not, whether we ever touch its fragments directly or only through comets, its message is already clear. The past is not gone. It waits at the edge, wrapped in ice, written in dust, preserved in silence. If the Oort Cloud is a time capsule, a storehouse of memory at the edge of the solar system, then what lies beyond it may remind us that most of the universe is hidden. The things we can see, the stars, the planets, the galaxies, the comets blazing across the night sky, are only a fraction of what reality contains. The rest is dark, not necessarily in the sense of shadows, but in the sense of invisibility. Dark matter, dark energy, structures we cannot observe directly, but whose presence we know from the ways they shape what we do see. Dark matter first entered our imagination not as a discovery, but as a problem. In the 1930s, astronomers studying galaxies noticed something strange. When they measured the motions of stars at the edges of galaxies, the stars were moving too quickly. By all rights, those stars should have been flung into intergalactic space, their speeds too high for the visible mass of the galaxy to hold them, and yet they stayed. The simplest explanation was that something unseen was there, some additional mass providing the necessary gravity. In the decades that followed, this mystery deepened. Spiral galaxies like our own Milky Way spin, their stars orbiting around the centre. If only visible matter were present, the outer stars should orbit more slowly, like planets around the sun. Instead, they orbit at nearly the same speed as stars closer in. This flat rotation curve suggests that galaxies are surrounded by halos of invisible mass, halos far larger than the galaxies themselves. The visible stars are just the bright core of something much vaster. We call this unseen substance dark matter, not because it is literally dark, but because it does not emit or absorb light in any way we can detect. It does not shine, it does not glow, it does not reflect. We only know it is there because of its gravity. It shapes the motions of galaxies, it bends light through gravitational lensing, it affects the growth of structures in the universe. By some estimates, dark matter makes up about 27% of the universe's mass-energy content. Compare that to ordinary matter, the matter that makes up stars, planets, people, oceans, and comets, which accounts for only about 5%. Most of the matter in the universe is invisible. The Oort Cloud, vast as it is, feels tangible compared to this. At least we can point to comets as evidence, see their orbits, glimpse their tails. Dark matter offers no such visitors. It remains hidden, silent, refusing to show itself except through gravity. Scientists have proposed particles, weakly interacting massive particles, sterile neutrinos, axions, but so far none have been detected. Dark matter remains a placeholder term, a name for something we know must exist but cannot yet touch. As if that were not enough, there is also dark energy. In the late 1990s, astronomers studying distant supernovae made a startling discovery. The expansion of the universe, far from slowing down under the pull of gravity, was accelerating. Something unknown was driving space itself to expand faster and faster. To account for this, scientists proposed dark energy, a mysterious force or property of space itself that pushes galaxies apart. If dark matter holds things together, dark energy drives them apart. And by current estimates, dark energy accounts for nearly 68% of the universe. That means that almost everything we experience, the planets, the stars, the visible galaxies, is less than 5% of reality. The rest is dark matter and dark energy, hidden structures we cannot yet explain. The Oort Cloud, enormous though it seems, is only a speck within that framework. To think of this is to feel the scale of mystery, the recognition that what we know is a fragment of what is. There is something deeply humbling in this. We look at the night sky and marvel at its vastness, but what we see is only the tip of an iceberg. Beneath the surface lies far more, unseen and unseeable, shaping everything. The Milky Way itself is embedded in a dark matter halo. The galaxy's spiral arms, its stability, its very existence depend on that unseen mass. Without dark matter, galaxies might never have formed. Without dark energy, the universe might not be accelerating. Reality as we experience it is shaped by things we cannot see. The thought of hidden structures resonates with human imagination. Throughout history, we have sensed that the world holds more than is visible. Ancient myths spoke of hidden realms, unseen spirits, forces beyond perception. Today, science speaks of dark matter and dark energy. The language has changed, the tools have sharpened, but the recognition is the same. Reality extends beyond our senses. We are always seeing only part of the picture. And in that recognition lies comfort too, because it reminds us that mystery is not an absence. It is a presence we have not yet understood. The Oort Cloud preserves the story of beginnings. Dark matter and dark energy preserve the structure of the cosmos itself. Together they remind us that the universe is layered, full of archives, full of hidden frameworks. To live within it is to live within a story much larger than ourselves. Imagine, for a moment, drifting at the edge of the Oort Cloud, the sun a faint star behind you, the galaxy stretching ahead. You're surrounded by silence, by icy fragments drifting unseen. But beneath that silence, beneath the visible stars, lies another structure. dark matter enveloping the galaxy, shaping its motion, dark energy driving the expansion of space itself, carrying galaxies apart. You cannot see these forces, but you are within them, as surely as you are within the cocoon of the Oort Cloud. They hold you, shape you, guide your motion. This is why hidden structures matter, not because we can observe them directly, but because they remind us that reality is never exhausted by what we see. The edges we draw, between light and dark, between known and unknown, are not limits but invitations. They invite us to keep looking, keep questioning, keep imagining. The Oort Cloud is one such invitation. Dark matter and dark energy are others. Each edge we find is really a threshold to something deeper, and so, when we ask what lies beyond the Oort Cloud, the answer may be that beyond it lies the galaxy's hidden scaffolding, the dark matter halo that holds us, the dark energy that carries us outward. The edge of the solar system is only one of many edges, each leading to another. The reality we inhabit is not bounded but layered, each layer revealing itself slowly, each one reminding us of how much remains unseen. When we talk about edges, we imagine something clear, a line, a wall, a boundary that says, here is where it ends, and beyond this lies something else. We are creatures of limits, used to shorelines, horizons, the edges of forests, the walls of rooms. But the universe does not always behave in the way our senses expect. The farther we look, the less certain the concept of an edge becomes. The Oort Cloud, for all its immensity, is not truly a wall, only a thinning of influence. The galaxy itself is not sharply bounded, but blends into the intergalactic medium. And when we step back even further, when we ask whether the cosmos itself has an edge, the question grows stranger still. Is space really infinite, or is what we call an edge only an illusion of perspective? Infinity is not easy to imagine. Our minds evolved to navigate landscapes with beginnings and ends. We can picture a road that stretches for kilometers, maybe even for thousands of kilometers. But when we try to imagine something that has no end at all, the thought loops back on itself. We reach outward in the mind, but there is always the temptation to stop to say, that must be far enough. And yet, if space is infinite, there is no far enough. No matter how far you go, there is always more. Astronomy suggests that the observable universe, the part we can see, is finite. Light travels at a finite speed, and the universe has a finite age, about 13.8 billion years. That means light from galaxies beyond a certain distance has not had time to reach us. The cosmic horizon is the farthest we can see, the limit of observation. But beyond that horizon, does space continue? The simplest answer is yes. There is no evidence that the universe stops at the edge of what we can observe. More galaxies, more stars, more space likely lie beyond, unseen but real. The observable universe is like a bubble of visibility, not a bubble of reality. Some models even suggest that space itself may be infinite. If the universe is flat in its geometry, and measurements of the cosmic microwave background suggest that it is, or at least very close to flat, then it may stretch endlessly in all directions. No edges, no walls, no end. Just more space, more galaxies, more structures, continuing without limit. In that view, the Oort Cloud is not the edge of the solar system in any ultimate sense, but simply one tiny feature in an endless expanse. But infinity is slippery. Some models propose that the universe is finite but unbounded. The analogy often given is the surface of a sphere. If you travel on Earth in one direction, you will never find an edge. The surface curves back on itself. You can travel forever without falling off, and yet the surface is finite. Space could be similar, not infinite but curved in higher dimensions, so that travelling far enough would eventually bring you back to where you started. In such a universe, the question of edges becomes meaningless. There is no end, no outside. The universe is all there is, wrapped into itself. Whichever model is true, What seems certain is that our intuition about edges does not match cosmic reality. The lines we draw, the edge of the atmosphere, the edge of the solar system, the edge of the observable universe, are conveniences, ways of organising thought. But they are not absolute. Each edge is really a transition, a change in what dominates, a shift in influence. The atmosphere fades into space. The solar wind fades into the interstellar medium. The observable universe fades into the unobservable. What looks like an edge is always a gradient. There is a kind of relief in this realization, because if the universe has no edge, then we are not confined. The cosmos is not a box, but an openness. The silence between the stars is not a wall, but a medium, something continuous, and in that openness there is room for everything, for galaxies, for comets, for dreams of travel, for questions without answers. And yet, infinity carries its own unease. If space truly stretches forever, then somewhere out there, beyond any distance we could imagine, matter may have arranged itself in patterns identical to ours. Infinite possibilities mean infinite repetitions. There could be another Earth, another you, another night sky being watched in another infinite stretch. It is not something we can prove, but it is a consequence of thinking about infinity seriously. The mind reels at the thought, both unsettled and amazed. For practical purposes, though, our edges remain meaningful. The Oort Cloud may not be the edge of reality, but it is the edge of the solar system as we can meaningfully define it. The observable universe may not be the edge of space, but it is the edge of what we can study. These edges help us orient ourselves, even if they are not final. They are markers on a journey without end, milestones on a road that continues beyond sight. Perhaps the illusion of edges is not a flaw but a necessity. Without them, we would be lost. With them, we can measure progress, tell stories, give meaning. The Oort Cloud feels like an edge because it is the farthest influence of the sun. The helopause feels like an edge because it is where the solar wind yields to the galaxy. The observable horizon feels like an edge because it is where light can no longer reach us. These are not ultimate edges, but they are edges for us, edges we can hold in the mind. So, is space really infinite? The truth may be beyond our grasp. We may never know for certain, but in asking the question, we already expand ourselves. We push against the limits of thought. We stretch imagination into regions where intuition falters. And in that stretching, we become part of the openness we're trying to describe. Imagine lying back and letting your thoughts drift outward, past the atmosphere, past the planets, past the Oort Cloud, past the galaxy itself. Outward and outward, never stopping, never finding an edge. At some point the mind protests, but if you let go, the thought becomes soothing. Not because you can picture it clearly, but because you do not need to. Infinity does not need to be pictured. It only needs to be felt as openness, as possibility, as the absence of walls. And in that openness, the Oort Cloud becomes not the end, but a threshold. A reminder that every edge is only an illusion, and that reality continues beyond every horizon we draw. When we think about the vastness of the Oort Cloud, or the seeming infinity of space beyond it, we picture great distances, enormous timescales, the slow drift of comets and stars. It is a view built on enormity. But reality is not only vast, it is also small. So small that the foundations of everything lie in particles and probabilities, in a quantum world that behaves in ways nothing in ordinary life prepares us for. At the edge of the solar system, where the visible fades into the invisible, where gravity is faint and silence is deep, it is tempting to stop at the scale of galaxies. Yet even there, the smallest scale is present. The Oort Cloud may be a cosmic cocoon, but each fragment within it is made of atoms, and those atoms obey rules that belong not to Newton's clockwork but to quantum mechanics. Quantum theory describes a universe that is not fixed, but probabilistic. An electron does not have a definite position until measured. It exists as a cloud of possibilities. A photon can act like a particle or a wave, depending on how we observe it. Entangled particles can influence one another instantly, across distances that defy common sense. These are not just curiosities of physics, they are the foundation of everything, the building blocks of comets, of stars, of the very molecules that form our bodies. At the cosmic border, where the Oort Cloud blurs into interstellar space, quantum mechanics might feel remote. After all, quantum effects are usually associated with the very small. But the truth is that quantum rules underlie all scales. The stars themselves shine because of quantum processes, nuclear fusion driven by the tunneling of protons through barriers they should not be able to cross. Without quantum effects, the sun would not burn, and the Oort Cloud would not exist. It is strange to imagine that the same physics that governs an electron's jump within an atom also governs the destiny of comets a light year away. But that is the unity of reality. The border between scales is as illusory as the border between systems. Just as the Oort Cloud is not a hard edge but a gradient, so too the line between the quantum and the cosmic is not truly separate. They are woven together, different expressions of the same underlying fabric. Quantum theory also challenges our notion of edges in another way. It tells us that nothing is ever fully isolated. A particle in one place can be entangled with a particle elsewhere, their states linked no matter the distance. If this is true at the smallest scales, then perhaps the universe itself is entangled. Perhaps the comets at the edge of the solar system are not just silent fragments, but participants in a network that spans the cosmos, subtle threads of connection invisible to our eyes. This way of thinking may sound dreamlike, and in a sense, it is. Quantum mechanics itself often feels like a dream, a set of rules that work perfectly in equations but defy intuition. To imagine the Oort Cloud as a quantum border is to let the dream expand outward, to picture icy bodies not just as frozen relics but as quantum systems, vibrating with uncertainty, connected in ways we cannot yet see. Consider the vacuum of space itself. We often call it empty, but in quantum theory it is anything but. Even in the void, particles flicker in and out of existence, virtual pairs appearing and vanishing in times too short to measure. This quantum foam is the background of everything, seething beneath the silence. At the border of the solar system, where we think of space as empty, this quantum activity still hums. The silence between the stars is never absolute. It is filled with fluctuations, whispers of particles that live and die in less than a blink. And then there is the question of measurement. In quantum mechanics, to measure is to change. The act of observing collapses a cloud of possibilities into a single outcome. If we were to send a probe to the Oort Cloud and sample one of its icy bodies, we would not just be retrieving frozen material. We would be collapsing probabilities into reality, turning potential into fact. The time capsule of creation is not only physical but quantum, its details shaped by when and how we look. This interplay between the quantum and the cosmic has led some thinkers to wonder whether the universe itself is a kind of dream. Not in the sense of unreality, but in the sense of fluidity, of probabilities that become fixed only when part of a larger whole. The edge of the solar system, then, is not just a place in space. It is a reminder that all boundaries are provisional, all edges porous, all realities dependent on scale. It is not hard to imagine lying beneath the night sky and letting such thoughts drift. To picture the comets of the Oort Cloud as frozen seeds, each one a probability wave waiting to be observed. To picture the galaxy as not only made of stars and dark matter, but also of entanglements, hidden connections that bind everything together. To picture space itself as alive with fluctuations, even in its deepest silence. Quantum dreams at the cosmic border invite us to think differently about edges. They suggest that the border between the solar system and the galaxy is not just spatial, but conceptual. It is where our intuitions falter, where we realize that scale itself is relative. The vast and the tiny are not separate but reflections of one another. The infinite and the probabilistic are two sides of the same coin, and in that realization lies a kind of calm. Because if the universe is quantum at its heart, then uncertainty is not an error but a feature. Edges are not fixed because they are not meant to be. The Oort Cloud blurs into the galaxy because reality itself is blur, a fabric of probabilities woven into structure. To accept this is to accept openness, to find peace not in certainty but in possibility. As you let that thought unfold, you may find yourself imagining the edge of the solar system not as a wall, but as a place of connection, a place where the quantum and the cosmic meet, where dreams and physics overlap, where uncertainty becomes the most reliable truth. To dream of the Oort Cloud in this way is to dream of reality itself, infinite, uncertain, connected, and always waiting to be observed. When we think of the Oort Cloud, it can feel remote, abstract, almost unreal. A sphere of icy fragments a light year away is not something we can touch, not something we can see with our eyes, and yet in imagining it, in studying the comets it sends inward, in pondering its place at the edge of the solar system, we often end up learning something about ourselves. The Oort Cloud, though outwardly silent, speaks to us in ways we might not expect. One of the first lessons it teaches is humility. The sheer scale of the Oort Cloud dwarfs anything familiar. Trillions of icy bodies scattered across distances so vast that even light, travelling at its impossible speed, would take months to cross from one side to the other. To imagine it is to confront our smallness, to recognise that our entire world, oceans, continents, histories, civilizations, sits at the very centre of something unimaginably larger. The edge of our influence is not the edge of reality. We are surrounded by immensities we can barely comprehend, but humility, when taken gently, is not diminishing. It can also be liberating. To know that we are small is also to know that we are part of something vast. The Oort Cloud is not separate from us. It is connected to us through gravity, through history, through the comets that sometimes fall inward. We are not the centre of the universe, but we are participants in it, woven into its structure. That perspective shifts how we see ourselves. We are not masters of reality, but part of a continuum, children of the same processes that scattered icy fragments into the dark. Another lesson lies in patience. The comets of the Oort Cloud orbit on timescales so long they defy imagination. Some take millions of years to complete a single circuit around the Sun. To us, bound by decades and centuries, this seems endless. But for the comets, it is natural. They drift, orbit, return in rhythms that ignore the brevity of human life. In that contrast, we learn patience. Our lifespans are short, but the universe moves slowly. The Oort Cloud reminds us that not everything must happen quickly, that some processes unfold over eons. It invites us to slow our thinking, to breathe with a wider rhythm, to accept that some stories are written in millennia, not moments. The Oort Cloud also reflects our relationship with memory. As a time capsule, it preserves the earliest materials of the solar system, fragments unchanged since before planets formed. When comets fall inward, they deliver these memories to us, offering glimpses of the past. In this way, the Oort Cloud is a mirror of our own impulse to remember. Just as it holds on to the story of creation, we hold on to our own stories. In libraries, in photographs, in spoken traditions. We too are time capsules, preserving fragments of experience to pass along. The Oort Cloud teaches us that memory matters, that what is preserved can shape what comes after. There is also the lesson of fragility. The comets of the Oort Cloud are bound to the Sun, but only loosely. A passing star, a galactic tide, Even the faintest of nudges can send them drifting away forever. Their loyalty is conditional, their connection tenuous. In that we see ourselves as well. Our lives are fragile, our societies delicate, our certainties easily shifted. We like to think of ourselves as stable, but the truth is that we too can be altered by forces beyond our control. The Oort Cloud reminds us to treat life with care, to recognise how easily trajectories change, how precious stability really is. And yet, fragility does not mean weakness. The Oort Cloud has endured for billions of years. Despite its looseness, despite the faintness of the sun's grip, it remains. Its endurance comes not from density or strength, but from scale and patience. In that, it mirrors a lesson for us. We do not need to be unbreakable to endure. We only need persistence, community, and time. The Oort Cloud survives not because each fragment is strong, but because together they form something greater, a structure vast enough to outlast disruption. The Oort Cloud also teaches us about perspective. From Earth, comets seem sudden, unpredictable, even chaotic. But when we place them in the context of the Oort Cloud, their appearances make sense. They are not random intruders, but natural consequences of orbits, nudges, and history. In the same way, our own lives can seem chaotic when viewed up close. Events arrive suddenly, disrupting the ordinary. But with perspective, with a wider view, patterns emerge. The Oort Cloud reminds us that context matters, that what looks random may be part of a larger rhythm. Then there is the lesson of connection. Every comet that falls inward links us to the edge of the solar system. Every icy fragment out there shares history with the material that formed Earth. We're connected to the Oort Cloud not only through gravity but through origin. The same disk of gas and dust that gave birth to planets also scattered icy bodies outward. To remember this is to remember that separation is an illusion. The edge is not apart from us. It is part of us, a distant cousin in the family of creation. And in this perhaps lies the deepest lesson. The Oort Cloud is both far and near. Far in that we cannot reach it, cannot see it, cannot touch it directly. Near in that its comets fall into our skies, in that its history is our history, in that its endurance is part of our own story. It is both alien and familiar, both edge and core. In reflecting on it, we reflect on ourselves. Creatures who are also both fragile and enduring, both brief and timeless, both separate and connected. The Oort Cloud teaches us humility, patience, memory, fragility, endurance, perspective, and connection. But above all, it teaches us openness. To think of it is to confront mystery without resolution. We do not know exactly how many comets it holds, exactly how far it extends, exactly what lies within it. And that not knowing is not a failure. It is an invitation. It invites us to remain curious, to remain open, to accept that some edges will always be just out of reach. As you let these thoughts rest, imagine once more the quiet of the Oort Cloud, the slow drift of icy fragments across unimaginable distances. Each one is a mirror, reflecting not only the history of the solar system but the qualities we find in ourselves. To study the Oort Cloud is to study us, small, fragile, enduring, connected, curious. The edge of reality is not only out there, it is within us, shaped by how we imagine, how we remember, how we endure. When you think of the Oort Cloud, after all this wandering, after tracing its cocoon-like vastness, after following its comets inward and imagining its connection to the galaxy, it becomes less a distant structure and more a place of rest. Not because it is soft, not because it is warm, but because it embodies the idea of an edge that is not final. It is both near and far, both ours and not ours, both history and possibility. To linger on it is to linger at the border of reality as we know it, and to recognise that every border is also a beginning. The Oort Cloud drifts in silence. Trillions of icy fragments orbit unseen, their paths stretched across millions of years. Some will never move closer, some will eventually slip away. A few, nudged by passing stars or galactic tides, will fall inward, lighting our skies as comets, brief reminders of that distant reservoir. Most will simply wait, suspended in patience beyond imagination. That patience is what makes the Oort Cloud soothing to think about, because in its stillness we glimpse a model of endurance. You might picture yourself lying within it, adrift on one of its icy fragments. The sun a faint star behind you, indistinguishable from others in the sky. Ahead, the galaxy, a river of light stretched across the dark. Around you, emptiness, so wide and so deep that distances blur into a kind of calm. Nothing approaches quickly, nothing demands urgency. The timescale of the Oort Cloud is too long for hurry. To rest in that vision is to let go of haste, to let go of tomorrow and yesterday, to breathe at the scale of billions of years. The comets drifting there are timekeepers, but not of days or seasons. They mark epochs. They remind us that life on Earth, for all its richness, is a moment in cosmic time. Civilizations rise and fall in less than a blink of one comet's orbit. The Oort Cloud keeps a slower rhythm, one that can soothe us if we let it. To hold that rhythm in your thoughts as you drift towards sleep is to align yourself not with clocks, but with eternity. And as you rest in that eternity, you might also remember that edges are illusions. The Oort Cloud feels like an edge, but beyond it lies interstellar space, and beyond that the galaxy, and beyond that perhaps infinity. Every time we imagine an edge, we find it dissolves into something larger. That thought could be unsettling, but it can also be deeply calming, because if there are no true walls, no final endings, then everything continues. The silence between the stars is not emptiness, but continuity. The edge of the solar system is not the end, but the beginning of the galaxy. The Oort Cloud is also a time capsule, carrying the past into the present. The comets it holds are fragments of creation, frozen since before Earth was born. When they fall inward, they carry messages billions of years old. To imagine those messages is to feel a connection to the deep history of the universe, to know that the past is never entirely lost. It waits at the edges, preserved in silence, waiting to be read. That too is a comforting thought, that memory is built into the cosmos, and that forgetting is never absolute. And then there is the lesson of fragility. The comets are loosely bound, easily perturbed, easily scattered. Yet the cloud as a whole has endured for billions of years. Its fragility has not prevented its survival. If anything, it has made survival possible, because what is fragile can bend, can drift, can adapt. The Oort Cloud teaches us that endurance is not about being unbreakable. It is about being part of something larger, something vast enough to last. To let that idea rest in your mind is to soften your own need for strength, to allow fragility to be part of survival. If you close your eyes now, you can imagine the Oort Cloud not as a cold, remote structure, but as a halo of belonging. The solar system rests inside it, wrapped in a sphere of icy fragments. We are not naked in the galaxy, but cocooned. The cocoon does not protect us in the way walls do, but it surrounds us nonetheless, giving us a sense of enclosure, a sense of place. We are not alone in emptiness. We are part of a system, part of a structure, part of a continuum that stretches outward. And as thoughts drift outward with it, the scale becomes soothing. The stars are far apart, yet they share the same galaxy. The galaxies are far apart, yet they share the same universe. We are far from the Oort Cloud, yet we share its origin. Distance does not erase connection, it only reframes it. The Oort Cloud teaches us humility, patience, connection, endurance, memory and openness. But perhaps what it teaches most of all is calm. To think of it is to think of silence, of slowness, of a scale so large that urgency fades. It is an invitation to rest, to let your mind drift outward into that cocoon, to let yourself be held by its vastness. So let yourself drift there now. Let the silence between the stars surround you. Let the faint pull of gravity hold you gently, like a thread connecting you to the sun. Let the comets orbit around you, slow, steady, patient. Let the galaxy breathe beyond, vast and quiet. You are part of it, woven into it, carried by it. The edge of reality is not an end. It is a place of rest, a threshold, a gentle reminder that everything continues. And as you breathe with it, slowly, calmly, you can let yourself drift too. Drift like a comet in the Oort Cloud. Drift like a thought in the silence of the night. Drift into rest, into calm, into the edge of sleep. Because in the end, the Oort Cloud is not only the edge of the solar system, it is a reflection of your own quiet, your own continuity, your own belonging to something larger. And in that belonging, you can rest. Thank you for drifting through this journey tonight. From the first thought of comets as messengers to the idea of the Oort Cloud as a cocoon at the edge of reality, we've wandered across distances so vast that time itself seemed to dissolve. And yet in the end, all of it has led back here. To quiet, to rest, to the simple comfort of being part of something larger than ourselves. If you found peace in these reflections, consider returning again, whenever you need calm, curiosity, or a gentle companion for sleep. And if you'd like to support this space, a like or a subscription helps keep these journeys alive. For now, let the thought of the Oort Cloud linger as you settle deeper into rest. The comets will keep orbiting, the stars will keep shining, reality will keep unfolding. All you need to do is breathe, let go, and drift. Good night.